Up, down, left, right. When I say these words, you instinctively know what I mean. As a three-dimensional being, those directions align with the universe as you know it. Yet, mathematicians and physicists insist that there's another dimension. But we just can't perceive it. The universe beyond 3 dimensions holds more secrets than you can ever imagine. And what's even more intriguing is how those secrets affect you every single day. Are you prepared to let go of your very limited view of reality? These are the secrets of the 4th dimension. The distance in thinking between humans and every other living thing on Earth is inconceivable. As the apex species, we've set the benchmark of knowledge. But are we truly qualified to do so if all we know is only a tiny fraction compared to what is truly knowable in the universe? Of all the gaps of knowledge we have, there's one thing we can't seem to grasp despite our many attempts to try. The 4th dimension. We can try to explain it, we can theorize about it, we can even attempt to visualize it, but it's like a constant blind spot built into us by a function of who we are as a species. Your intuition right now is telling you that you're sitting still. But are you? No, you're not. At least, not according to physics. Right now, you're moving, maybe not through space, but through time. You're aging. And the rate at which that's occurring is decided by mysterious forces. The forces you've never been taught to think about. Take maps, for example. If you go searching for the objective truth, you'll find that every map of the Earth is actually distorted by necessity. The reasoning is straightforward. You can't make a sphere flat without distorting it. So while maps serve their purpose, they're not an accurate representation of the world. If we observe them accurately, every map of the Earth fundamentally misses its mark. We've navigated through the world using bad maps our entire lives, and we've managed to get by because we understand both the 2-dimensional world of maps and the 3-dimensional world of our shared reality. But since we have no physical evidence or experience of the 4th dimension, how can we be sure that our 3-dimensional maps are sufficiently accurate as navigational tools? Let me paint that picture with an example. If we were 2-dimensional creatures existing on a 2-dimensional plane, traveling would be a lot simpler. Using a 2D map, the shortest distance between London and New York looks like a curved line towards the Arctic. But if that's applied in 3D, geometrically speaking, the real shortest distance between both locations would be through the Earth's crust. It's obviously impractical, yet it highlights the fundamental difference between dimensions. So take it up a notch to 4D, and you start to see how mind-bending a 4th dimensional reality really is. Right now, we might currently be traveling millions of miles through 3D space to reach a star, but in 4D, some theories suggest that there might be a version of a straight line that could make that distance similar to just a few inches long. What if we're only taking the best route we can contemplate because 3 dimensions doesn't reveal the true thickness of the universe? It's not fiction or a shower thought. Humans have been confidently wrong about the nature of reality before. Remember when people thought the universe revolved around the Earth? Or when we thought atoms were the smallest particles in the observable universe? The best thing about science is that new information always makes us better. Understanding the true motion of the planets helped spur a chain of ideas that led to the discovery of gravity. Meanwhile, learning that we could go even further than atoms into the subatomic has helped us with technology. The very transistors powering the device you're using to watch this video would not have existed if we accepted atoms as the actual smallest thing in the universe. So when we explore the 4th dimension, we aren't just running random mind experiments here. We may be grasping at knowledge that might one day totally change the world. As fun as it is to explore 4D, though, there is a bit of a language problem that we will inevitably bump into. We don't have any words for 4-dimensional directions because, frankly, we've never really needed them. But we can at least try to visualize and explain it in ways that hopefully do it justice. And then there's the next problem: framing. The fourth dimension is a hot topic in two fundamentally important disciplines, mathematics and physics. The mathematicians got here first and understood the fourth dimension as a purely geometrical concept. So to them it has nothing to do with time, it's just shapes and space. But then Einstein comes in and shocks the world with his own claim: time. Einstein believed that time was the fourth dimension, and this evolved into a physics-based view of 4D. So, while we will inevitably explore the two versions of 4D, they are two acts of the same story. Just remember that as we go along. But before we actually start looking deep into the realities of the fourth dimension, we first have to ask, what even is a dimension? Well, let's strip it back to something almost painfully simple, so bear with me here. A dimension is just a direction that you can move in. That's it. If you're standing on a straight line, you can only move forward or backward in, well, one straight line. So the world to you has one dimension. There's only one independent direction available to you. Now, imagine you're standing on a flat sheet of paper instead. You can move forward and backwards, but you can also move left and right. That's two dimensions, two independent directions. Add one more. Suddenly you have space. You can move forward, backward, left, right, up, down. Three independent directions. And that's the world that we live in. A dimension is simply a new way to move that isn't just a combination of the others. So when mathematicians talk about a fourth dimension, they are saying something very specific. They're saying there is another direction. A direction that is completely separate from up, down, left, right, forward, backward. Not diagonally, not any angle, not very far away. We are talking a totally new, bespoke direction. And if you're anything like me, this is where your intuition starts to fail. Because every direction you've ever experienced can be described using just three numbers: length, width, height. Your brain has never needed anything more than that. So trying to imagine a fourth spatial direction is like asking a 2D creature to imagine up. It just wouldn't look like anything to them. It would sound impossible, almost mystical. But from our perspective, it's just normal. And that's the weird idea. If a two-dimensional being couldn't imagine up, could it even begin to understand a sphere passing through its world? It would only see a circle appear out of nowhere, grow, then shrink, then vanish. To it, that would look like magic. To us, it's just geometry. So, when physicists and mathematicians talk about a fourth dimension, they aren't necessarily talking about something supernatural. They're talking about the possibility that there is another direction woven into reality, and one we simply cannot turn towards. Our brains are built to imagine three independent directions, and that's the limit. When we try to picture a fourth spatial direction, our mental image collapses. It neither turns into something three-dimensional, or it becomes abstract and mathematical. We can understand the pattern logically, we just can't see it directly. It's not that the idea is impossible. It's that our imagination does have a ceiling. But hey, you know what? Who says we can't try anyway? In 1884, a random Victorian school teacher wrote one of the strangest books ever published. It was about a world that was completely flat. Its citizens were triangles, squares, and circles, all living out their lives on an endless sheet of paper, completely unaware that anything more could exist. The book was called Flatland. The main character is a square. Yeah, his name is literally a square, and he's considered middle class in their world. In Flatland, women are simple lines and considered dangerous for their pointy ends. Triangles are a tier above them, followed by squares like our protagonist, and then polygons. At the top are circles, and they are considered the absolute rulers of society. Such a society feels similar to ours in some ways, both in its flaws and its strange standards. At one point in the story, a square's life takes a serious turn as a 3D sphere passes through Flatland. But he doesn't see it as a sphere. he simply sees a dot that becomes a circle. He watches it grow, shrink, and eventually vanish. It's a confusing feeling. A square watches what is essentially the mold of what he considers as a fellow person, morphing and distorting between sizes with ease, as if this strange sequence is totally natural. Everything about a square's understanding of reality turns on its head. How could a dot, something even less than a line, the lowest of flatland society, transform into a circle, widen easily, and also vanish into the distance just as quickly as it arrived? Now you can see how this book brilliantly captures the scary reality of being a three-dimensional object that happens on a four-dimensional object. What would it feel like to see a four-dimensional creature taking a stroll through reality? It would first appear as a strange, three-dimensional shape that materializes out of nowhere, then it morphs into things we recognize, but can't quite put a finger on. And then, almost in an instant, it would disappear with no explanation. The creepiest part of all of this is that a square never even got to see the 3D object, only its two-dimensional shadow. That's the exact same way we would experience a four-dimensional object. We would only be able to see its shadow, and yet what we'd experience would completely break our minds and our understanding of reality. If only the cross-section of the fourth dimension is that profound, visualizing the real thing is not that different from insanity. A 4D creature would possess the ability to reach inside of a locked room without opening it, the same way we have the ability to touch the middle of a circle drawn on paper without crossing its circumference. Edwin Abbott came up with Flatland thanks to the Victorian-era fascination with mystics and spiritualists. Many of these individuals turned out to be con artists, but they did provide a fascinating case study for what higher dimension interactions could look like. A 4D being would certainly be able to pull a rabbit out of an empty hat, so it's not like the deceptions were unfounded. During that period, many claimed that the dead were living in a higher dimension, just out of reach. It's admittedly a creepy thought that brings a new meaning to popular visions of loved ones who passed away. What if, in their ascension to a new dimension, they gained the ability to cast 3D shadows that we see as ghosts and spirits? I don't know. Being on the wrong side of a dimension can feel invasive, but it's also helpful to know what it might feel like. To a 4D being, you're just as clueless as the average flatlander who creates rules around seemingly foolish ideas. However, you have something the flatlanders don't, and that is a really good imagination. Our exceptional imagination as humans allows us to bend rules a little better than any other species could hope to. Therefore, imagining our way through 4D is not pure speculation, but rather a solid way to bypass our physical limitations. So what I'm going to do now is help you build something in 4D. Here's how. First, we have a single point that extends into a line. It's basically what we established earlier for 1D. However, to upgrade it, we'll draw a few more lines to make it a square. And now we're in 2D. We extend the shape even further and we add a new perpendicular direction. After completing the lines, we now have a cube. Cubes are something we can draw as a representation of 3D, even on a 2D surface. So naturally, what would the 4D equivalent of the cube be? Thankfully, there is a real answer available, and it's called a tesseract. Remember how we've used shadows as a step below representation of each dimension? I want you to hold on to that thought, because what we'll do here is create a 3D shadow of this tesseract, a 4D object. See how strange it is to look at? It's almost like an optical illusion that pays off if you pay enough attention to it. The weird rotating shape isn't random or trying to be imposing, it's just the strange logic-bending rules of 4D at play in a 3D perspective. Some of you may have even seen this online and wondered what it was, but now you finally have your answer. Even if you're not necessarily equipped with what to do with this odd looping box thing, there's probably some sense of empowerment in being familiar with the shadow of a higher dimension. Well, forgive me for this, but I'm going to immediately take away that sense of empowerment. Because if a 4D creature had darker intentions towards you, there's absolutely nothing you could do about it. Let's say by some miracle, you came across a precious, rare diamond. I'm talking about Scrooge McDuck levels of wealth here. You could swim in it and you have to store it in a big cartoon vault. How would you keep it safe? Now, let's say you keep it in a sealed room built by science's greatest minds. They've developed the technology to keep even atoms away from penetrating without the right passcode. And you feel satisfied with your efforts, and then you step out of the facility. 2 minutes later, the alarm goes off. You assume it's an error in the system until you check the CCTV footage, and your precious diamond is gone. Every sensor in the room failed to go off, so how is that even possible? Well, to everyone presently inhabiting the Earth, it falls into two equally mystifying categories. Either it's an illusion, or it's magic. To a 4D creature, it's just a random Tuesday. Its ability to take the diamond without the limitations of a 3D sealed box is the exact same geometric logic we use to open doors, lift objects, and interact with everything around us. To really understand this, let's go back to Flatland. Imagine you're a 3D burglar and your victim is a square, a 2D creature. This flat person stores their most valuable possessions inside a perfectly sealed square vault. The walls are all solid lines with zero visible cracks from their point of view. To them, it is absolutely secure. Now you, a 3D being, walks up to this vault. You don't have to break the walls, or crack the safe, or disable any alarms. You simply reach down from above, lift out the object, and just leave. From the 2D person's perspective, the object would simply vanish. No wall breached, no door opened, every boundary is still perfectly intact. And it's the same way with your 3-dimensional vault. The 4-dimensional creature would simply take the diamond and move in a direction that you can't access. From your perspective, the diamond would disappear. Sensors would show nothing and the room would remain perfectly sealed. A 4D being's understanding of us would probably be instinctive, and much like the geometry of stealing a sealed diamond, it can do even weirder things. Take our own bodies, for example. It would possess the ability to see the interior surface of your body, like your organs, your brain, and your circulatory system. A 4D doctor would likely be incredibly efficient at removing cancerous tumors. There would be no need for incisions or special tools. The tumor would effectively vanish from your body and then appear in their hand. For a concept this rich, it's a tragedy, knowing that we'll never get to see it in its full glory. Although 4D is impossible to see, the reason why we can't see it is also an equally interesting exploration. Your brain doesn't show you reality in its most concrete sense. We only see a model of it. For example, if you went into a mosquito's mind and saw through its eyes, you'd be colorblind. The world would be pixelated and you'd be extra sensitive to motion. As a trade-off for the terrible eyesight, you'd gain the ability to see heat signatures, giving you precise visuals for the juiciest veins. Now think of any living thing with eyes or senses, and these variations feel endless. The reason mosquitoes see the way they do and we see the way we do comes down to evolution. The model of reality we evolved to perceive is what our genes prioritized for our survival. As humans, we can't feel magnetic fields the way some birds do. We can't see ultraviolet light. We can't hear a majority of the sound spectrum. Slowly you realize that we are missing out. And the 4th dimension might belong to one of the categories we never evolved to perceive. What if it's not an absence in reality, but an absence in us in that case? The limits to our perception do feel like a huge hole in our evolution, but those limits can't stop us all. In fact, Einstein didn't need to see it. He found a way to detect its effects and prove that it shapes everything around us. And what he found is what comes next. In 1908, a former mathematics teacher named Hermann Minkowski stepped onto a stage in Cologne and changed the way that we describe the universe. Years earlier, he had taught a young student at the Zurich Polytechnic. That student considered his lectures overly abstract, too mathematical, and too detached from reality. I'll spoil it right now. The student's name was, say it with me, Albert Einstein. By the time Minkowski gave that 1908 lecture, Einstein had already published Special Relativity. He had shown that time slows down at high speeds and that space itself contracts. But he had done it all through physics with equations and algebra. He did not yet see the universe geometrically, but Minkowski did. In that lecture, Minkowski made a very bold declaration. Space and time, he said, are not separate things. They're woven together into a single four-dimensional fabric. What we experience as space and what we experience as time are just different aspects of the same structure. He called it space-time. When Einstein first heard this framing, he dismissed it. He referred to Minkowski's approach as a kind of superfluous learnedness. It sounded like mathematics for the sake of mathematics. But then something clicked. Einstein realized that Minkowski had uncovered the deeper structure behind his own equations. Special relativity was not just a set of physical rules, it was a description of geometry, gravity, motion, time itself. They were not forces acting inside of space, they were features of space-time's shape. Even Einstein needed a moment to see it, and once he did, physics was never the same again. To better understand it, I want you to answer me this question. Where's your phone? Go on, leave your answer in the comments down below. I'll start. Mine is currently laid down flat, sitting just over there on that table, almost away from my line of sight, almost. When is my phone in this exact position? Right now. But what is now? 10:53 a.m. is how I would answer you. When asked this question, you likely answered by describing where it is in space, but then you left it at that. But when it is an equally relevant detail that completes its location in space-time. It's a little strange, but hang in there with me. I'll give you an even simpler way to understand it. According to Einstein, you are always moving through something called space-time. Even when you feel like you're completely still, you are still moving. The question isn't whether you are moving, but how that movement is divided. The strange rule is this: the faster you move through space, the slower you move through time. And the slower you move through space, the faster you move through time. You can picture it as a constant overall motion. Imagine that everyone is always traveling at the same total cosmic speed. But that speed can be split between space and time. If you're sitting still in your room, almost all of your motion is going into moving forward through time. Seconds pass normally and you age at the rate that you would expect. But when you start moving through space, even just a little, a tiny portion of that motion shifts away from time and into space. When that happens, time slows down slightly for you. At everyday speeds, this effect is so minuscule that you never really notice it. But it is real, and it is in fact measurable. Astronauts orbiting the Earth age slightly slower than people on the ground because they are moving faster through space. The difference is tiny, but it has been scientifically confirmed. If you could travel close to the speed of light, the effect would become dramatic. From your perspective, time would feel normal, but to someone watching you from Earth, your clock would tick much more slowly. There's a lot more fancy science at play here, but the overall result stands, and that's pretty mind-blowing. Remember when I said that to answer where your phone is, you should include when your phone is in that spot? Well, here's the full truth. If you didn't account for the time when it was there, on a universal level, you'd be incorrect, even if it's left untouched for 24 hours. Your phone is actually moving through time, the same as you and everyone around you. To take that idea even further, here's something that will genuinely mess with you. Clocks may be wrong, at least in a universal sense. My now and your now are fundamentally different depending on where we find ourselves and how fast we're moving through space, and I'm not just talking about time zones here. Even just a short distance away from someone moving at a different speed, we might experience the same events in totally new temporal ways. Imagine a train moving at a high speed. Then suddenly, two lightning bolts strike both ends at exactly the same time. As a bystander waiting by the train tracks, you watch it happen and your jaw drops in awe. Meanwhile, let's switch perspectives. Now you're a passenger sitting in the middle of that same train. This time, what happened was that one bolt struck before the other. It was only a slight delay, but you unmistakably heard a loud boom towards the front, followed by another at the back. Same two bolts, same moment, two different perspectives. Neither person is wrong. From where they stand, both of them got it right. The issue here is that the concept of at the same time is not a universal truth. Everything relies entirely on where you are and how fast you're moving. This is called the relativity of simultaneity, and it dismantles an idea most of us have always accepted without question, that there's one universal clock ticking the same for everyone around the world. 4D shows that the present is a relative concept, same with regular concepts like directions. Past, present, and future all exist simultaneously, like all directions in our three-dimensional space. With a difference in speed, time transforms and contorts itself. On that note, maybe you shouldn't accept time as a shared experience and instead embrace it as a personal one. So far, we've only explained space-time and 4D on a personal level. So, how does our own planet respond to these newly revealed truths? This is the part where everything you thought you knew about gravity gets dismantled. Newton taught us that gravity was a force, the invisible pull between objects that possesses mass, dragging them towards each other across empty space. For centuries, it was enough to know that gravity predicts the motion of planets and explains why things fall. Nobody really challenged his findings. But from Einstein's point of view, he saw something totally different. To him, there is no pull and there is no force. Rather, what we call gravity is the shape of space-time itself. What that means is this: stars, planets, and anything possessing significant mass aren't just reaching out and grabbing things. Instead, they are so big, they warp the entire fabric of space-time around them. This creates a curve so that everything nearby, including light, simply follows that curve. For us, that means the Earth isn't pulling the moon towards it. That's not an accurate way to describe what's happening. The Earth is actually bending the geometry of space-time around it, and the moon follows accordingly. The mass of the moon isn't enough to overpower the Earth's space-time bending influence. To put it in simpler terms, if I had a soccer ball and I placed it on a stretched piece of fabric like a bedsheet, the fabric would dip in the exact spot that I placed the ball. Now, if I were to bring a tennis ball onto this same fabric, the ball would roll up to the dip created by the soccer ball. After all, the soccer ball has a higher mass, so it dictates the bending. It's easy to see how one might think the tennis ball is attracted to the soccer ball. But no, the tennis ball, much like the moon, is only pulled by the change in geometry caused by something with a higher mass. This is what Einstein meant when he said that gravity and space-time are inseparable. The fourth dimension goes beyond just tracking events in time. It can actually bend, and it has a shape. This was confirmed by gravitational wave detection in the LIGO observations from 2015. So yes, scientists have evidence that all this is in fact real, and we're only learning more. We've moved past pure theory, and now we've realized that space-time is physical enough to influence our universe significantly. Taking everything we've discussed about curved space-time and pushing it to its absolute limit, we find science fiction's favorite event: a black hole. Black holes happen when an object is so massively dense that it creates a curve in space-time, which essentially becomes a point of no return. The geometry governing space-time doesn't dip like with the soccer ball and the bedsheet. Instead, it spirals inwards so severely that nothing nearby can ever follow a path that leads back out. That includes matter and even light. Since time is relative, like we explained earlier, the black hole also influences it significantly. Time near a black hole doesn't just slow down slightly, like with our astronaut example. It actually slows down to almost a complete stop near a black hole. If you ever found yourself hovering near the edge of a black hole, you're better off exploring the cosmos than returning to Earth. Why? Because even if you were there for what felt like an hour, the Earth you left behind would be gone, and you'll find that centuries, if not millennia, have passed. The more space-time curves, the slower time moves within it. It's the same fabric we've come to know with planetary masses, only this time, the rules are taken to an extreme conclusion. Each time you open Google Maps, you're relying on information from a bunch of satellites orbiting the Earth at high speeds located far above the surface. GPS satellites move fast. According to the rules of special relativity, these satellites have clocks that are measurably slowed down compared to ours on Earth. But they are also sitting in weaker gravity than what we experience on the surface. That distinction makes a huge difference, because according to general relativity, this also speeds up their clocks. So there are two opposing effects going on with GPS satellites. It sounds like a lot to deal with, especially since they are both significant enough to matter. How this issue is resolved comes down to the brilliance of engineers. They ensure that the gravitational effect actually wins here, meaning that GPS clocks are programmed to run slightly faster overall. Every single day, engineers must correct for both of these factors by using Einstein's equations, not just as an interesting academic exercise, rather as a necessity. Without the corrections, the correlation between what your GPS says and where you are would be completely off by several miles. The fourth dimension isn't a theory waiting to be proven. It's already a part of our infrastructure in the modern world. We've explored a concept that's already difficult on its own, but add two strong interpretations of it, and we've got an even wilder mystery on our hands, one that creates a powerful premise. If a dimension is an independent axis of information, then 4D is a way to open our eyes beyond the boundaries of reality and into a higher dimension. Geometric 4D showed us that space has more structure than what our senses can comprehend. Meanwhile, the physics 4D showed us at that time isn't separate from that structure. Together, they are proof that the universe is richer than what we are evolutionarily equipped to perceive. Every time humanity learned something new about our world, we became better off because of it. The Earth wasn't really flat. The sun didn't orbit around us. Time wasn't fixed. All these ideas have had direct consequences that shaped our world today. The fourth dimension is that kind of expansion. We may never get to see it directly, but our ability to think in it, build with it, and navigate from it is no small thing. In the end, that's what makes us different from the Flatlanders. We started this journey by asking an important question. Are we prepared to let go of reality if we ever manage to look beyond 3 dimensions? Having come this far with me, are you? If you are, may I interest you in even more dimensions? Watch this video to find out more. There's a quiet assumption running beneath almost everything you do. It doesn't announce itself. It doesn't ask for your trust. It just sits there underneath your alarm clock, your appointments, your deadlines, the way you say, "see you soon," and mean it. The assumption is this, that right now is something every one of us shares. Somewhere tonight, 2 people are standing in a kitchen watching a clock tick towards midnight. They've decided this is the moment. An anniversary, a birthday, or even a new beginning. They're holding on to the idea that when the clock strikes 12, something real will shift, that they'll cross a threshold together at the same instant. And they're not alone. Right now, all over the planet, millions of people are counting on the same invisible agreement, that there is a now. and that it's universal. That the present moment is the one thing that we can all point to and say, this is where we are, together. But physicists went looking for that moment, and they couldn't find it. Not in the laws of physics, not in any equation, not anywhere in the most complete description of reality that human science has ever built. The present, the one thing you are more certain of than anything else, simply doesn't exist. But if time doesn't have a now, then why do you feel it so completely? And if that feeling is something your mind is making up, rather than something the universe is giving you, what exactly are we all living in? These are the terrifying secrets buried in the one dimension you never think to question: time. To understand the dimension of time, we first need to understand spatial dimensions. I think my past self would explain it a lot better. Let's strip it back to something almost painfully simple, so bear with me here. A dimension is just a direction that you can move in. That's it. If you're standing on a straight line, you can only move forward or backward in, well, one straight line. So the world to you has one dimension. There's only one independent direction available to you. Now, imagine you're standing on a flat sheet of paper instead. You can move forward and backwards, but you can also move left and right. That's two dimensions, two independent directions. Add one more. Suddenly you have space. You can move forward, backward, left, right, up, down. Three independent directions. And that's the world that we live in. A dimension is simply a new way to move that isn't just a combination of the others. Thanks, me. I'll take it from here. You know, that version of me had no idea that he was going to be showing up here, but I do remember filming it in the past, and if I remember, then he still exists somewhere in the universe, doesn't he? Which means the version of me speaking to you today isn't just here for the present moment, because even right now, I might be saying or doing things that will only makes sense if you have future me giving you context. This will make sense in the future, but for now, 3 dimensions, or 3D as we know it, only focuses on the 3 dimensions of space. The tangible world we can point to and physically interact with. However, 3D is only useful for us if we're locating a place, not an event. And I don't mean an event like a gathering or a birthday party. I mean an event literally, which is a thing that happens. When your mom goes out for work and reminds you to take the chicken out of the freezer, you immediately understand that there's a timeline for this event. Assuming she gets back from work by 6 p.m., then that means you have a 2 to 3 hour window to take that chicken out. Now, according to 3 dimensions, you know where the chicken is currently located. It's in the freezer. But 3D doesn't account for the intricate nature of your mom's instructions. If you take it out too early, it begins to spoil before she's come back. But if you take it out too late, you get a tongue lashing. The specific valid moment to take it out, that is what the 4th dimension is all about. The moment. Therefore, every real event needs 4 numbers to make complete sense. 3 for where it's happening and 1 for when. And that 4th number is time. For most of human history, space was space and time was time. They were 2 different things running alongside each other but never touching. Space was the stage, time was the clock on the wall, completely separate. Then, Einstein arrived and quietly dismantled that separation. What Einstein showed through his theory of special relativity is that space and time don't just coexist. They trade off against each other. If you were to move faster through space, time slows down for you. Slow down in space and time speeds up. They aren't 2 separate measurements, they're 2 sides of the same measurement. A few years later, a mathematician named Hermann Minkowski took Einstein's equations and made the implication impossible to ignore. He showed that what we experience as space and what we experience as time are both just different angles on a single four-dimensional fabric that he called space-time. If every event follows a fixed four-number address, then that means you can picture them all laid out together as one complete grid, and each event, no matter how small or insignificant, sits somewhere on its own permanent coordinate. So yes, your birth has a four-number address. Your first day of school has one too. Same with your graduation and every other moment that you have ever experienced. Although those events are memorable and set in the past for you, they haven't disappeared from existence. We like to think of time like it's a movie, with each new frame replacing the last, creating a clear indication of where the timeline currently sits. But unlike movies, every point in reality sits like a point on a map. There is no current frame or current page to turn to. Many physicists favor this reading, and they even have a name for it: the block universe. Past, present, and future are all laid out at once, every moment as real and as permanent as any other. But you can see this creates a problem. If every moment is equally real, if the map just sits there with no preferred direction, then where does the feeling of forward come from? Why does time only ever seem to move one way? Here's what makes this strange. The laws of physics don't actually have a direction. Look at this video of two pool balls colliding. Now play it forwards normally. Play it backwards. It looks normal. There's nothing in physics that objects to either version. The equations work identically in both directions. Time at that level of fundamental physics is completely reversible. Now picture this. That's totally different. You watched it and you already knew this can't be reversed. You will never see those shards leap off the floor and seal themselves back into a cup. Same with a scrambled egg or an ice cube melting. The direction is obvious, instinctive, and absolute. So, here's the contradiction sitting at the heart of reality itself. The laws of the universe have no preferred direction, but every single thing that you experience does. If nothing in physics points one way, why does everything in life feel like it's moving forward and never back? Well, the answer is hidden within something that has been in motion since the very first moment of the universe, and scientists call it entropy. The basic idea is this. At any given moment, there are vastly more ways for things to be disordered than ordered. And the universe, left to its own devices, drifts towards disorder simply because disorder is more likely. Think about what it actually takes for something to be a cup. It needs a specific shape, a minimum volume to hold liquid, and then walls sturdy enough to carry it, a form friendly enough to drink from without spilling. The requirements of a cup are strict. The window is pretty narrow. A cup has to have a particular set of qualities. Now, think about what a shattered cup looks like. There are no requirements for the shards. They can be large or so small they embed into your foot weeks after you've finished cleaning. They can be jagged or smooth, scattered across the floor, or just piled neatly in a corner. There is no wrong way for a cup to be broken. The number of possible shattered states is almost infinite, while the number of possible cup states is vanishingly small in comparison. This is what entropy actually means. It isn't a state of chaos for chaos's sake, it's simple math. When you have far more ways to be disordered than ordered, disorder becomes the overwhelmingly statistical favorite, not because the universe prefers it or some force is actively pushing things towards chaos, but because if you pick a random outcome from all of the possible outcomes, you are almost certainly going to land somewhere messy. An unscrambled egg, a reassembled cup, Those outcomes aren't necessarily forbidden by any laws of physics. They are just so astronomically improbable that they may never happen once in the entire lifetime of a finite universe. The universe isn't moving towards disorder on purpose. It's just that disorder has the numbers on its side, and that's where time's direction comes from. So, thanks to entropy, we have a model for understanding the difference between the past and the future. What we call the past just means a more ordered world. Meanwhile, the future is harder to predict or pin down because it has unfathomably more possibilities. It even reflects in how we remember and imagine things. When you think of the past, you can pinpoint exactly when you ate for breakfast down to the second. You can recall lottery numbers, sports scores, election results. But the future? Well, that looks like disorder. There are no lottery numbers you can predict, no guarantees. The only thing separating the past and the future for us is an increase in entropy. The direction of time isn't in the laws of the universe. It only feels that way because reality is a slope and we live on the downhill side of it. That rush you feel moving towards the future isn't the universe moving, it's you sliding down the slope of entropy. But here's what that quietly implies. If the direction of time is something that emerges from probability rather than law, then it isn't woven into the fabric of the universe the way we assumed. It's a consequence, a side effect of where we happen to be on the slope. And that raises a question that we've been glossing over without realizing it. We've been talking about sliding down this slope as if everyone does it the same way, as if that slope runs at one universal speed for every person, every clock, and every corner of the universe. What if it doesn't? What if your slope runs faster than mine? The whole concept of time, as we understand it, rests on one strange fact about light. And to see why it's so strange, we need to start somewhere ordinary. So picture yourself, standing on a platform as a train speeds past you. Someone on board rolls a ball forward. To them, the ball moves at rolling speed. But to you, standing still on the platform, it moves at rolling speed plus the train's speed. The two speeds stack up. For the most part, that's how motion works, and it's the most intuitive thing in the world. Swap the ball now for a beam of light. Common sense says the same rule should apply. The light should pick up the train's speed on top of its own, just like the ball did. But it doesn't. You, on the platform, and the passenger on board measure that beam moving at exactly the same speed, and not approximately the same, exactly the same. It doesn't matter if you're running toward it or racing away from it or chasing it on the fastest rocket ever built. Light always clocks in at around 300,000 kilometers per second. No exceptions, no adjustments, and no stacking. How weird is that? Speed is just distance divided by time. If light measures the same for everyone, no matter how they move, then their distances and their times can't match. Something has to give, and what gives is both space and time themselves. The universe would rather warp your ruler and slow your clock than allow light to travel at any other speed. This reveals something deeply fascinating about the nature of the universe, that space and time are not fixed neutral containers that everything happens inside of. They can bend, they can stretch and run at different rates depending on how you are moving through them. When you're sitting still, you're not moving through space at all. All of that motion is spent moving through time. In essence, you are racing towards the future at maximum speed while you're not moving physically at all. But when you start moving through space, some of that budget gets diverted into your space speed. You're trading speed through space for speed through time and vice versa. This isn't a weird quirk of time or anything. It's how the universe works. Space and time are interconnected in an undeniable way. The best way to look at it is that time is a resource, and you are spending it just by existing. Though the metaphor has a limit worth pointing out. Simply put, you can't run out of the resources, and you can't choose how to spend it. You are always spending the full amount. The only thing that changes is how much goes into moving through space, and how much of that budget is left over for moving through time. Astronaut Scott Kelly spent nearly a year aboard the International Space Station while his identical twin, Mark, stayed on Earth. When Scott returned, a landmark experiment called the NASA Twins Study measured how a year in space changed his body down to his genes. They discovered that orbiting Earth at a much greater speed than his twin left Scott roughly 5 milliseconds younger than his brother. And sure, 5 milliseconds doesn't sound as fancy as what we got to see in Christopher Nolan's Interstellar. But the point isn't in seeing a stark difference. The point is that the theory of relativity is factually proven. There are no measurement errors or illusions going on with space and time. Everyone's clock is actually running at its own rate. You're sliding down the universe's slope of entropy at a pace only you possess. This creates a small dilemma in the way we see the world around us. Think back to the couple holding hands, vowing to transition to new beginnings together at midnight. They believe that time is one thing they can count on in this chaotic world. They're both very wrong. We exalt the clock of time as something that keeps us relative to one another, yet we have lived in different motions our whole lives. Our clocks have always disagreed. And if they can't agree on how fast time runs, there's a worse question waiting for us. Can they even agree on what's happening right now? Now, by definition, is a universal moment. But according to time, it's unique to the individual experiencing it. A slice through the grid of space-time that connects everything happening at the moment. Which slice counts as now depends on motion. If you were to move differently, your slice tilts. And because no one's motion is the true motion, no one's slice is the real now either. Physicists call this the relativity of simultaneity. The problem is that most people never get to acknowledge the variance in slices because differences tend to be so subtle, it's hard to feel anything is different at all. But when you include motion in the mix, the perception shifts. Astronomically, even a microscopic difference in motion creates a huge gap in which events count as now. Imagine two people who pass each other on a sidewalk. They're strolling in opposite directions at a regular walking pace. Although they're moving differently, their slices of now seem insignificant to anyone here on Earth. But that tiny difference, when observed from the Andromeda galaxy, creates a whole new version of now for either person. To put it into perspective, the physicist Roger Penrose poses an interesting scenario using this distant galaxy. Andromeda is 2.5 million light years away. That single moment of two people walking across each other on the sidewalk from Andromeda actually happens days apart. Two directions, two perspectives, infinitely different times across the entire scale of the universe. The weirdest part is that there's no canon event to point to, no master clock the universe keeps in a back room that settles who's right and who's wrong. And this isn't about us being too primitive to measure it yet. We are never going to invent a better instrument someday that finally syncs everyone's time up. That fix is impossible. It doesn't exist. Reality genuinely has no fact, no real element about whose now is the real one, because there is no real one. Billions of versions of this moment exist, all true, and there's nothing anywhere that decides which is correct. It's not like the universe is doing any of this on purpose to keep us confused. If anything, it's us humans who have overrated our influence over reality. We deluded ourselves into thinking our shared experiences meant that a universal present was guiding us forward through time. We were wrong. Our universe refuses to have a present. The shared now you have always imagined, a whole planet counting down towards midnight, every living person standing in the same instant, all of that was never something the universe held for you. It feels special living in such moments here on Earth, but the reason is completely mundane. And that reason is we are all sharing a big blue spaceship drifting through the endless cosmos. So of course, our slices of now seem to coincide. But that slice being somewhere we can agree on is more like an accident than a cosmic fact. The universe never crowned us as anything more important than what we really are. Our shared present, the thing we stake anniversaries and countdowns and New Year's kisses on, turns out to be a local fluke. A consequence of sharing the same rock, moving at the same speed through the same tiny corner of an indifferent cosmos. If you were to stretch past that bubble, the agreement dissolves. From the universe's perspective, there is no now, and there never was. We just never had a reason to look far enough to notice. And yet, here you are, feeling it completely. That's the part physics has no answer for. Not the direction of time, entropy handles that. Not the relativity of clocks, special relativity handles that. The thing physics can't account for is the one thing that you are most certain of in this moment. The feeling that something is happening, that this is now, that you are here inside of it and not watching it all happen from outside. Physics is the most complete description of reality that we, as a species, have ever built. Every moment is accounted for. Every coordinate in space-time is mapped and described. And yet, nowhere in any of these equations is there a variable for the present. No term that says, this moment, right here, specifically this one, is the one that is real. The math works perfectly without it. The universe apparently doesn't need it. Think about a book. Every page is already printed before you open it. The story is fixed, it's finished, and it's complete. But nothing in that book itself marks one page as the one being read right now. The book doesn't know, or frankly doesn't care, where you are in it. You know where you are, you create the bookmark, but never the book. The knowledge of the present lives in the reader and not the text. So physics is that book. It describes every page of reality with extraordinary precision, every moment, every coordinate, every event across the entire history of space-time. But it contains no bookmark. There is no mechanism in the laws of reality for flagging one moment as current. No equation that reaches out of the mathematics and says, hey, guys, right here, this one, this is now. We've settled it. If physics has no arrow to direct us and no now to ground us, then where do we really belong? Here's where that question stops being abstract. If every moment is equally real, if nothing in physics gives the present any special status over the past or the future, then the implications don't stay philosophical for very long. They get very personal very quickly. Your death already exists. It's not approaching you. It's not waiting somewhere up ahead just down the road. It's already real, already fixed, sitting at its own address on the map the same way this moment is. Think of the person you would never want to lose, whether it's a parent, a partner, whoever that is for you. The day you lose them isn't coming. It's already there, finished and permanent, as real as the moment that you are living in right now, whether you've reached it or not. We tell ourselves that that dreaded day is coming for us, and somehow, as strange as it is to admit, there's a comfort in that. Coming means maybe later, maybe never. Maybe you'll find a way to manage it on your own terms. You know what? Maybe you'll be ready. But the block universe doesn't bend like that. Death isn't on its way to you. It's not in an Uber arriving at your destination soon. It is already there, and there is no version of the timeline without it. You're like someone tracing a route across a map with their finger. The map doesn't change when you trace it. You're moving towards things you'd give anything to avoid, and yet not a single line will shift. The destination, the map, was always drawn. You're reading a finished book, mistaking yourself for the writer and the page you're on for the page being written. But the page was already there before you ever opened it, and so are all the ones after it, right up to the very last. But that same fixedness cuts the other way, and this is a truth worth holding on to. If the worst day is permanent, so is the best one. The day you were happiest is still there, finished and intact exactly as it was or will be, and nobody that you've lost is gone. They're not erased. They're elsewhere on the map, in the moments you shared, in the memories of them that you keep, exactly where you left them. After the passing of his lifelong friend Michele Besso in 1955, Einstein wrote a letter of condolence to Besso's grieving family. In that letter, he said that for those who accept physics, the separation between past, present, and future is only a stubbornly persistent illusion. A month after the letter, Einstein himself passed away. Although it was intended for a grieving family, that message also represents a kind of comfort that cuts deep into how time works. To Einstein, Besso was never truly gone. The moments they shared still existed. They still do. The block universe takes something from you, yeah, but it also gives something back. And what it gives back is permanent, in exactly the same way loss is. I want to try something. Close your eyes and think of nothing. No darkness, just nothing. Think of nothing as an object in your mind. Imagine a universe where all matter has completely decayed. Photons and leptons are too far apart to form any processes, and the temperature is near absolute zero. There's nothing, or more accurately, nothing observable. All the stars have burned out. Black holes are now gone and disappeared. No change is occurring to make one moment distinguishable from the next, and perhaps, worst of all, there is no conscious being to witness this great nothingness. What I'm describing here is maximum entropy, the final stage of the heat death of the universe. The concept of maximum entropy is based on the second law of thermodynamics. In simple terms, this law of physics suggests that disorder increases over time in a closed system, a system where no energy leaves or enters. Energy will become more evenly distributed, moving from hot to cold areas to reach equilibrium. Heat itself is this transfer of energy. That's why your coffee gets cold when you leave it out too long, or why your house requires a heating system to work continuously to stay warm in the winter. This process is also irreversible. While you can reheat your coffee with more energy, you can't regain the energy that was dispersed when it was first heated up. That's just gone forever now. There's no capturing it out of the air. If you consider the universe as such a closed system, then we have a big problem. Because according to the second law of thermodynamics, eventually, entropy will increase until all energy is fully dispersed. And once this happens, no processes can form. All the lights go out and we enter a permanent state of nothingness. In a famous short story by the science fiction writer Isaac Asimov called The Last Question, he asks us to consider this lights out scenario. And more importantly, he poses an important question. Can humanity prevent the state of maximum entropy, or are we and the universe doomed to a dark, cold fate? But before we can address the last question, we need to address several other big questions first. We have many entropy-related problems to solve before the very distant future arrives in some untold trillions of years. On a side note, I would like to recommend taking a moment to read the 9-page short story The Last Question after watching this video. It's by no means necessary to understand any of what we will be discussing today, but it would act as a very nice companion piece, and I'm sure you can find it online. To live what many would consider a full life, we have to resist entropy at every turn, and we do this by consuming energy. It keeps our metabolism running, which in turn keeps the human body in a state of low entropy. This is something we have in common with all life on Earth, and potentially life elsewhere in the galaxy. Despite the proliferation of life, living has historically been a constant struggle. Before agriculture became a thing, food and water weren't always available. The intake of food from foraging and hunting would have been inconsistent. Even with the proliferation of agriculture, crops have failed due to weather conditions. Even today, countries still experience famines, though often as a result of political disorder as opposed to any kind of act of nature. Overall, though, we've managed to make low entropy a lot easier than when Homo sapiens first evolved. To keep ourselves at this low entropy state, however, we have to cause more entropy in our environment. To keep ourselves warm enough to live during colder weather, we have to use energy from the environment. We might burn wood or use a gas-powered furnace. Baseboard heating draws electricity from local power plants, which may use liquid natural gas or coal. Heat pumps are more efficient at using energy as are nuclear power plants. The power you can get from one pellet of nuclear fuel, for example, can power one home for several months. However, despite how efficient our technology can be, we're still causing some entropy. We're turning some energy into an unusable form to drive turbines. That energy disperses, and in the language of entropy, it's becoming disorganized. So, does that mean our planet is doomed to its own heat death long before the universe's heat death? If the Earth is a closed environment, then this would entail that no matter how efficient we become, we'd still ultimately experience maximum entropy at some stage or other. In this closed environment, we would only control how long our planet will last as a life-sustaining habitat. Inevitably, our planet would run out of usable energy. But here's the fortunate thing for life on Earth. Our planet isn't a closed system. Energy enters from a source that we're all, I hope, very familiar with: the sun. Our local star is our main source of energy, actually. It's what made life on Earth possible in the first place. It sends us energy, and we make tremendous use of it. That's why when we consider how best to limit entropy with our power needs, capturing energy from the sun may be our best option. Unlike fossil fuels, nuclear energy, and coal, solar fuel is nearly limitless. The only limited energy it uses is in the tools to capture that energy. They, of course, require resources and are subject to decay themselves. The sun's energy is critical for life, but it can be a curse in certain conditions. Greenhouse gases in the atmosphere absorb light, causing the bonds between atoms to vibrate. The energy and heat remain trapped rather than being released into space. Life on Earth requires a range of temperatures to maintain a low entropy state. As global temperatures rise, the planet becomes less hospitable to many life forms. Many plant species won't survive in these increasingly warm environments. The animals that require that fuel source will die off as well. Eventually, the Earth will become hostile to life, putting our ability to survive into question. Fortunately, thanks to our open system, we have a lot of control over the entropy at the planetary level. We just have to figure out the scientific and political solutions that harness the sun rather than turning it against us. We currently have ways of capturing the sun's energy. Solar panels are proliferating at a rate never seen before. They've become cheaper and more efficient than any other form of electrical generation. And while the influence of oil and gas companies is holding back some progress, the business case for solar may be too strong to be stopped. Solar holds a lot of promise for our immediate future, but the dreams of scientists imagine something far greater for capturing the energy of the sun. After all, Earth only receives 1,361 watts per square meter of irradiance from the sun, while the star itself actually outputs 380 billion quadrillion watts per second. The energy Earth receives is still substantial though. 8 hours of it could power our planet for the entire year. However, it may not be enough for our future ambitions. This limitation has led scientists to dream up concepts such as the Dyson sphere, a hypothetical megastructure that surrounds a star and captures all of its radiant energy. When scientists search the stars for evidence of extraterrestrial intelligence, they often look for signs of a Dyson sphere. The thinking is that an intelligent species, with enough time, would try to capture all of its sun's energy. On the Kardashev scale, this would be a Type 2 civilization. A Type 1 is a civilization that is able to utilize all the available energy sources on a single planet. Humanity is currently at 0.7449, just in case you were wondering. As long as our sun continues to shine, humanity has the opportunity to sustain a low level of entropy. But that introduces another important question that is addressed in the opening of Isaac Asimov's The Last Question. What I say is that a sun won't last forever. We're safe for 10 billion years, but then what? This is a question the character Lupao poses in the year 2061. In the world of Asimov's The Last Question, humanity has stopped using coal and uranium and instead has captured the sun's energy from a station that circles the planet. They have enough power to send ships to Pluto and back as many times as they please. But when the sun goes out, well, that's it for life on Earth. They'd have to travel to other habitable planets to escape extinction. We still have billions of years left of the sun's energy before it all turns into a red giant and swallows us all, but that isn't forever. With technology that harnesses the full power of the sun, we could potentially capture enough energy to make traveling to a new habitable planet a very real possibility. But of course, there are many technological hurdles that would need to be passed. Perhaps the most obvious challenge is that the closest hospitable planet will be several light years away. Currently, we are nowhere near being able to travel at the speed of light. One of the strongest candidates so far for speedy space travel is a light-driven nano spacecraft. The breakthrough Starshot can theoretically reach 15 to 20% of the speed of light. The concept involves a fleet of about 1,000 spacecraft the size of a centimeter, propelled by ground-based lasers. The spacecraft would also deploy sails in a diameter of 5 meters to be propelled by light. If all goes according to plan, the Starship would be able to reach the closest star system, Alpha Centauri, within 20 to 30 years. The ship would then take 4 years to send back information about the surface of a potentially habitable planet, Proxima Centauri b. Since we humans are not the size of ants, the breakthrough Starshot project will be completely unmanned if it ever takes off. However, it's quite possible the billionaire investors have lost interest in the project due to their notoriously fickle nature. So maybe don't hold your breath for any updates. But if we are to take humans to other planets, several issues need to be addressed. Even if a ship is able to move at a similar speed to the breakthrough Starshot, we do have another problem with entropy. Conscious humans only live so long before their bodies become too disorderly to continue functioning. The passengers on board such a ship would have to enter some kind of cryogenic stasis, otherwise they probably wouldn't live long enough to arrive at this new world. Currently, we don't yet have the ability to sustain life this way, or more accurately, we don't have a way to revive life. There are currently a few projects underway, however. One example comes from the startup Tomorrow.bio, which is operating the first cryonics lab in Europe. Patients interested in the possibility of prolonged life can pay roughly $200,000, yikes, to be frozen immediately following their death. These patients aren't simply frozen, as that would irreversibly damage their tissue. The company first replaces all the water in the body with a cryoprotective agent. This solution consists of dimethyl sulfoxide and ethylene. The patients are then cooled quickly to negative 125 degrees Celsius. After that, they're slowly cooled from negative 125 to negative 196 degrees. Once they reach that temperature, they're stored in a facility in Switzerland, where they can wait as long as their temperature is maintained. The idea is to resurrect these stored individuals once there's a cure for the conditions leading to their death, and after we've figured out how to bring someone back from cryostasis. However, no one has been successfully brought back to life thus far, and it may simply be impossible to avoid resurrected patients suffering from severe brain damage. That is ultimately to say that there's no clear way to suspend life just yet. An alternative to cryostasis is the idea that travelers on board could also be a part of an intergenerational trip, with no realistic plans to see new planets for themselves. Such a project is currently underway, aiming to make interstellar travel possible by 2100. It's called the 100-Year Starship, a collaboration from the Defense Advanced Research Projects Agency, or DARPA, and NASA. The teams involved need to address one primary challenge: speed. Our current fastest moving object in space is the Parker Solar Probe, clocked at 430,000 miles per hour. At that speed, we wouldn't reach Proxima Centauri for 6,617 years. For comparison's sake, we don't have any known human texts that date back 6,000 years. But there are some promising solutions for speeding up a human-carrying starship. You essentially have two options: burn more fuel or develop new technology. The former would require an impractical amount of fuel or access to solar energy, which would be less accessible the farther away you are from the star. Fortunately, there have been big advancements in thrust technology. Nuclear fusion converts energy more efficiently and produces less radiation than existing nuclear power. Recent studies suggest that a fusion-powered spaceship could reach speeds greater than 62 million miles per hour. That would reduce the travel time to Proxima Centauri b to 45 years. With that speed, crew members would be capable of living through the entire voyage. But of course, there are yet more potential hazards. The hull of the ship would have to be strong enough to withstand micrometeoroids struck at high speeds. Keep in mind that a grain of sand traveling at 90% of the speed of light would contain enough kinetic energy to match a small nuclear bomb. There's also the fact that lying around all day with limited movement is very bad for the body. You would be at much greater risk of obesity, type 2 diabetes, and possibly even death. Passengers would need the ship to provide artificial gravity and room to move around to avoid serious health problems. Scientists will also have to contend with the radiation out in space. All of our space missions thus far have been protected by the Earth's magnetosphere. You've probably heard of space madness in film and television. Well, it isn't real per se, but studies have shown that several hundred days of isolation with a small crew can cause real strain on relationships. Many of them become antagonistic, which is a serious concern, given that these trips will likely take decades. We also have to consider the ethical concerns associated with interstellar travel. What if one or many of the passengers want to return to Earth in the middle of the journey? Would the plan allow them to return, or would it require them to follow through? That would be an extraordinarily painful circumstance for all involved. It could even turn violent, leading to a mutiny. The trip would certainly be long enough for passengers to change their minds from a sense of longing and anguish. If the trip spans several generations, you also face another ethical scenario. It's one thing for people to choose to live their entire life aboard a spaceship. It's another for people to be born on that ship and then forced into that life. They, of course, wouldn't be able to choose one way or the other. But having said that, aren't we all in a similar circumstance? None of us chose to be stuck on planet Earth with our population of over 7 billion people and our endless conflicts. Perhaps the circumstances only so different. One other potential solution is straight from science fiction, which in turn was based on scientific theory. I'm referring to the concept of the warp drive. If you've ever watched Star Trek, you're probably somewhat familiar with the concept. Instead of trying to travel through space in a linear fashion, the warp drive would theoretically bend space-time around your ship. It would contract the space-time in front while expanding it behind. This would allow the ship to travel at the speed of light without breaking the laws of physics. As it stands, however, the power required for such a ship would require nearly infinite energy. Unless some breakthrough in our understanding of dark energy comes along and changes everything, warp drives may have to stay on the USS Enterprise along with the best episodes of Star Trek. In our attempts to escape the entropy of Earth and our Sun, perhaps we're overlooking the greatest opportunity to avoid disorder: our own flesh and blood. What is aging but the body's entropy bringing us to an end? It's the orderliness and disorderliness of our living systems. The human body, if left alone, would become disorderly very quickly. It requires energy to operate life systems that slow down this process, and what we're talking about is food, of course. Eventually, despite all of our best efforts, we lose the ability to maintain a low entropy state. This condition is commonly known as death. Entropy also increases when the body is in a diseased state. Orderliness decreases at the cellular level. As we age, we show external signs of entropy. The elasticity of our skin decreases, leading to wrinkles that we desperately try to hide. We typically become less able to contribute energy to work as we get older. This is why most of us will retire at some point, I hope. It's possible that our pathologizing of old age stems from this concern about being less useful for work, similar to how energy dispersed is no longer usable. The less useful we are for work, the less productive we are for the whole. It's not hard to see this shaping our attitude towards the elderly and our own signs of aging. Aside from our efforts to prevent and cure diseases, we don't put a lot of serious effort into prolonging human life and usefulness. Meanwhile, clues in nature suggest the possibility of immortality and constant renewal. This may surprise you to hear, but there are several species of jellyfish that basically live forever. When the immortal jellyfish dies in its medusa stage of life, it sinks to the ocean floor and begins to decay. This is where things start to get interesting. Its cells reaggregate, but not in its medusa form. It reemerges into a previous stage of life, the polyp. From there, it blooms into a baby jellyfish, floating along in the ocean. What's amazing about this process is that the jellyfish not only avoids death, but returns in a lower state of entropy. It gets to thrive again instead of simply decomposing at the bottom of the sea floor. We currently have no way to borrow genes from the immortal jellyfish, but by studying them, we may learn ways to slow our own entropy. Or, hey, we might just gain an appreciation for a creature who's managed to achieve eternal life. But even if we were able to crack the code of immortality this way, we'd still be vulnerable to physical annihilation. Given enough time, we'd all die of some specter of physical violence, whether it's intentional or not. Perhaps then we need to think beyond the flesh and consider a disembodied life. Well, we'd be able to travel a lot lighter after all. Before we continue, I want to share something we've been working on. On this channel, we make a lot of heavy videos, from physics to philosophy, psychology to quantum mechanics. And while researching them, we end up reading a ton of incredibly interesting books, most of which get condensed into these relatively short videos. But those books are full of insights that we've always wanted to share more deeply, especially now, in an age where AI gives us instant answers and fewer people are taking the time to really sit down and read. We want to encourage something different, slowing down, taking in ideas more gradually, actually diving into these books in a way that our videos don't allow. So we're launching something new, the Aperture Book Club. In this video series, I'll be reading these books aloud and sharing my thoughts with you in real time. And you can share yours with me in the comments. It's going to be a more long-form, reflective style. The first episode will be on the live tab here on YouTube. We're starting with a compilation of Seneca's letters, one of the most influential Stoics of ancient Rome and someone Marcus Aurelius learned a lot from. If that sounds interesting, I'll leave a link so you can set a notification and join me when it goes live. See you there. For interstellar travel, the body might be our biggest bottleneck, a weight that will tether us forever to our solar system and the fate of its star. But what if we could separate the mind from the body? What if we were as light as code that could hitch a ride on the breakthrough starshot or its government-funded alternative? But that does beg a pretty important question. How possible is the transfer of human consciousness into the machine? Mind uploading is the hypothetical process of transferring a person's mind into a computer. That's everything from your sensory experiences, your memories, your emotional responses, and your cognitive abilities. This isn't just meant to be a copy. It's intended to capture your subjective experience. You would be immortal in the digital world, provided no one accidentally unplugs the computer. I would assume that there's a robust backup power system in place in case of outages too. This whole concept relies on the assumption that consciousness arises entirely from the physical processes of the brain. And if that turns out to be true, then a very sophisticated computer would be able to replicate all of the brain's functions, including consciousness. Whenever I read about mind uploading, I always have one big question that I haven't seen convincingly answered. Would my conscious experience actually continue into the machine, or would it simply be a copy? One response is to suggest the continuity of consciousness is an illusion to begin with. Our awareness is actually just fragmented moments held together by the brain's internal mechanisms, including memory. This is very similar to the Buddha's original teachings. He described the feeling of the continuous I, or self, as simply the succession of mental states, with one state conditioning the next. A good defense of this position can be found in the Ship of Theseus thought experiment that goes something like this. Imagine Theseus's ship is preserved by replacing every plank one by one. Eventually, no original part of the ship remains. The paradox is, with no remaining part from the original, is it still Theseus's ship? When we apply this paradox to consciousness, something interesting happens. Much like the planks, our neuronal processes are constantly being updated, and yet we still experience ourselves as a continuum of the same self. Thus, is it reasonable to suggest that if you replaced every part of your brain with a computational equivalent, bit by bit, your conscious experience would continue? And once the pieces were entirely replaced, could consciousness not be sent over to another capable machine? Well, the potential issue with this line of reasoning is that it rests on a pretty big assumption. That you can reduce consciousness to physical processes. That consciousness is simply a byproduct of physical, observable brain activity. The physical description of the brain leaves out the lived aspect of experience. By reducing consciousness to the physical observations, you're just sidelining consciousness. You're not explaining it. That's what's known as the hard problem of consciousness. The physical explanation of the brain leaves out what it's like to exist and to experience. There remains an unbridgeable gap between the physical world and consciousness. How then would we ever know whether our continuity of consciousness, even if it is just illusory, could successfully transfer over to a machine if we couldn't verify the subjective experience? If you were able to transfer the mind to a machine and then back again, you could ask a person what it was like, whether they believe it was the same conscious experience that entered or not. But you could still never trust their testimony, as they would have the same memories of being a person, then a machine, and then a person again. They would not be able to tell whether they were the same continuum of consciousness. I'm not suggesting that there's necessarily something more to consciousness than what we could physically account for. Just that we can't be certain that we've managed to account for the entire mind, as we'll never have access to the lived experience from the external physicality. However, if our consciousness ends and a new one begins, that's still a very human continuum, even if it's not the original person being carried over. It may be more like an act of creation that could aid our struggle against maximum entropy. Humanity may one day be able to colonize another planet. Perhaps we send digitized human consciousness in small robot bodies at high speeds, sailing on beams of light. And then these highly intelligent machines use the resources of the new planet to build bigger bodies that can construct a more hospitable environment. Humans then arrive on the spacecraft powered by nuclear fusion to a new home that is well set up for their survival. Over millions of years, their population expands and then extends to more planets across the galaxy. Millions more years pass as humans spread across the galaxy and perhaps find ways to inhabit distant galaxies via technologies that we can't even begin to comprehend now. We likely have to leave our bodies behind at this point, and instead use lightweight avatars that are so efficient they require next to no energy. As billions of years pass, stars burn out one by one, and only digital versions of ourselves are able to exist. We're nearing the point now of maximum entropy, which leads humanity to confront the last question. Can we prevent the heat death of the universe, the end of ourselves and all processes in the universe? Is it possible that all things must necessarily end, no matter how great our prowess in science? Well, the good news is that there's hope. Maximum entropy is not a guarantee, and has actually been suspect ever since we noticed that the universe is constantly expanding. Maximum entropy occurs in a closed environment, but if the universe is always expanding, it technically isn't closed off. Order can continue to increase indefinitely. Life itself is a complex form of order, and it is uniquely able to produce more complex order. The continual expansion of the universe affords life the opportunity to continue creating more and more complexity. In this condition, there's no limit to the generation of order. But the story doesn't end there. There's a popular new theory that suggests the universe's expansion may begin to slow. And if that's true, well, we may be back to the heat death hypothesis. But before we get ahead of ourselves, we still don't know whether the universe will end or continue forever. But in the absence of an answer, there's no good reason not to commit to bold acts of ingenuity and creation, so don't stop. Let there be light. Although humanity may never be able to stop the heat death of the universe, a sufficiently advanced alien civilization might be able to. Click the video showing on screen right now to learn all about the highest levels of civilization in the universe. Where are you right now? Take a look around. Take stock of your surroundings. What do you see? The inside of your car on the commute to work? An office cubicle? Your bathroom floor? Your bedroom ceiling? Now, notice how you described it to yourself. You may have been literal. A wooden wall, the smell of something cooking on a stove, a neighbor's dog barking, a picture frame, a desk, a tangle of cables. Or maybe you reached for broader strokes. The interior of your room, a slice of blue sky, or the traffic that you're stuck in. However you described it, you just did something most people never think twice about. You observed the world outside of yourself. You took in that data and you trusted your mind to build an accurate picture of where you are. But what if you got it wrong? What if you aren't seeing the world as it is at all? What if I told you that there's a force that keeps you from experiencing the totality of what is around you? It keeps you blinkered, narrows your attention to only what it wants you to see. It edits your perception in real time, colors the world so you fit neatly in with the crowd. It uses half-truths, recreations, and outright fabrications. It steers you through life while insisting, every step of the way, that what you are seeing is real. You can't escape it. You can't outthink it, because it isn't working against you from somewhere else. It's a part of you. It is you. This is one of the most terrifying theories in neuroscience you'll ever come across. Your brain is incredibly powerful, yet so vulnerable at the same time. packed into your skull is the most powerful tool for mapping the world around you, but one that is also uniquely exposed to being misled. Think about what your brain has to do every second that you're awake. It doesn't have the time or the energy to carefully analyze every photon hitting your eyes or every sound wave reaching your ear. So it cheats. It takes shortcuts. It fills in gaps with assumptions and decides in advance what's probably true based on what's worked before. That's not a flaw bolted onto an otherwise perfect machine. That is the machine. The same shortcut that lets you recognize a friend's face in a crowded room in a fraction of a second, the same assumptions that let you catch a ball without solving a single equation, are the exact mechanisms that can be hijacked, manipulated, or turned against you. Things like logical fallacies that we lean on to dodge complicated thoughts or ideas that clash with what we already believe. And it doesn't stop at the individual level. There's social pressure too, the pull to toe the line. We're social animals, and our own brains reward us for falling in step with the group. Psychologists call this groupthink. It's easy to just go along with what everyone else believes and seeing what they're seeing because that's what our brains want to do. There are parts of our brain that drive this social cohesion. These devices are specialized neurons called mirror neurons. If you've ever wondered why yawning is contagious, well, you have your culprit, as your mirror neurons are compelling you to yawn when you see someone else yawning. The reason for contagious yawning is to pass a message through a social group. That message is, well, things are quiet right now, but we should stay alert. And when we yawn, we are keeping our minds sharp when otherwise we might be inclined to doze off. It's like meerkats. If everyone is alert, the whole group will be much more likely to detect any incoming threats. Our mirror neurons are also responsible for empathy. When someone stubs their toe, we cringe along with them, even if we aren't stubbing our own toes. Our brains are stimulating empathy by simulating pain, and that shared experience brings us closer to the people around us. On top of all that, mirror neurons are responsible for our ability to learn an action just by observing someone else performing the same action. In our infancy, we learn a lot about how to relate with the world around us by watching our parents or other authority figures. It's in this way that behavior is quietly passed down from one generation to the next. But these mirror neurons can also take us down strange and dark paths. Before we get into that, here's something worth sitting with. If perception itself is this unreliable, human memory is worse. It doesn't just fade, it gets rewritten a little every time you retell it. And that's something I deal with on two levels. The big metaphorical, who am I, really, version, and the much more annoying day-to-day version. When making these videos, I talk with a lot of the team and also with experts, research calls, brainstorming sessions, interviews, and for the longest time, I'd either completely forget everything I heard and have to re-watch the entire meeting back, or walk away with a notebook full of half-finished scribbles and a memory that, ironically, wasn't filling in the gaps very well. In 1518, a craze swept the people of Strasbourg, a region that today is part of France. A woman named Frau Trophia and her daughter, Fräulein Emma Gotz, began to dance in the streets of Strasbourg. There was no celebration planned for the day, and there was no music playing. But soon they would be joined by others, some of whom were dancing with such a single-minded obsession that only death had the power to stop them. By mid-August, the mysterious affliction had affected up to 400 people. The dancers were moving spasmodically, their bodies drenched with sweat. Many collapsed mid-dance, and others wore through their shoes and stained the flagstones of their town with bloody footprints. There are disagreements with the death toll, but historians estimate that on average, 15 people a day were dying due to hunger or acute heart attacks at the peak of the incident. And then, by September, it was over. The Strasbourg dancing epidemic came and went, and left clergy, physicians, epidemiologists, and historians scratching their heads. The incident is one of the earlier examples of what is referred to as mass psychogenic illness, an anxiety condition that spreads through tight-knit communities. By 1518, Strasbourg had experienced a succession of famines, high grain prices, an outbreak of syphilis, and a recurrence of leprosy and the plague. The people were, simply put, at their wits' end, and tensions were high. With a population constantly in survival mode, mental health declined and created a populace primed for a collective crash-out. Stress and cognitive load have been linked to higher rates of suggestibility. If you've ever had to cram for exams or stay up until the wee hours of the morning finishing a paper that's due the same day, then you probably know the feeling. How stress starts taking over every part of you until it becomes harder and harder to think properly, and then, bam, you snap at everything and everyone. You stop thinking rationally through problems and you start taking shortcuts. Maybe you've noticed that while you're in a stress hole, just trying to get that last bit of the project done, that the people around you begin to take on that pressure as well. Or maybe you've been the other person, watching a loved one spiral further and further and feeling yourself get stressed just by being near them. The mood is contagious. Soon enough, everyone is having a terrible, terrible time. The people of Strasbourg were exposed to extreme stress by their environment. They were neurologically susceptible to suggestion. Because of these two factors, an entire population shared the same collective hallucination that there was a very real disease that was ravaging their town, forcing townsfolk to dance without end. To be clear, there was no dancing plague, but for the people living in Strasbourg, it was very real. Their perceptions and even their health was influenced by this social phantasm. They experienced something as though it was very real. They suffered and died of a fake disease that, in the moment, felt as real as the ground they were standing on. And Strasbourg wasn't an isolated incident of mass hysteria. Other such incidents have occurred throughout history, up to and including the evil clown panic of 2016. Maybe you remember that too. Rumors on the internet about people dressed as clowns attacking other people on the streets. Perhaps there were some isolated incidents here and there, but the coulrophobia, the fear of clowns, that resulted was everywhere for a time. I even had friends warning me, without any sense of irony, to watch out for dangerous clowns. Weird times. There weren't any roving bands of clowns menacing people in the dead of night, but a shared social belief had managed to prevail on otherwise rational people that there were clown-masked assailants lurking in every corner. On that note, technology and the internet in particular have done a lot of heavy lifting in demystifying a lot of urban legends. But at the same time, misinformation and disinformation have both been given a powerful avenue to spread through the populace and further warp perceptions away from reality. The scary part of all of this is that these perception-warping empathic contagions aren't just limited to stressed-out populations. Our language and culture have a huge effect on our understanding of the world around us. Pre-Socratic sophist and philosopher Gorgias of Leontini argued that the physical world could not be experienced except through language, and that the truth of existence as we know it is filtered through our sense of aesthetics. Gorgias claimed that only through language could we figure out the physical world. The truth of reality, then, is based on cultural preference or a functional consequence of our upbringing. Language forms the bedrock of our thoughts. Our experience of the world is influenced by the words that we have access to. With gendered languages like German, a bridge can be beautiful or elegant because the German word for bridge, Brücke, is gendered feminine. But with Spanish, the word for bridge is puente, gendered male, so bridges are often described with masculine coded words like strong, sturdy, or imposing. And it's the same with grammar. When someone you know walks into an antique store and accidentally breaks a plate, an English-speaking person would say, "Oh, well, so-and-so broke a plate." Where in Japanese you would say, "the plate broke." Notice how one linguistic structure creates guilt even though it was an accident, and the other simply recounts events without accusation. Language determines your thought patterns by creating or removing avenues for you to interpret your experiences. Your thoughts and feelings themselves are limited by the words that you have available to you. We've talked about how culture, language, and our social environment can shape our hallucination of reality. With strong critical thinking skills or weaker mirror neurons, we can decode and navigate situations that would otherwise have us throwing our lot in with the mob, dancing in the streets of Strasbourg, or checking under your bed for killer clowns. But there's something that no amount of rationality, no amount of reality checking can solve. Our physical brains themselves are so much more capable at leading us astray. Anil Seth, a British neuroscientist and professor of cognitive and computational neuroscience at the University of Sussex, has researched in depth the connection between our perception and our lived experience. Through the course of his research, he has studied and mapped out the processes and mechanisms that drive our brains and shape our perceptions. Seth's claim that the brain isn't experiencing reality but rather interpreting it holds up to scrutiny. Our eyes aren't sending images to our brain. They're absorbing light using photoreceptors, which then send electrical signals to our brain, which then decodes this information, and only then do we see. It's the same with all of our senses. We experience the world around us only inasmuch as our sensory organs are translating inputs into electricity that our brain then has to interpret. Our brains are complex biological machines. A delicate web of sensory devices allows our brains to build a complete picture of the world around us. Each of our senses, sight, taste, hearing, and touch, allow us to navigate our surroundings with confidence. But these sensory organs, the eyes, the ears, the nose, tongue, and mechanoreceptors, are not our brain. They're just relay nodes that take outside inputs and translate those inputs into signals that are then fed into the brain. Our brains do all the heavy lifting from there, translating those signals into conscious experience. So, I have a question for you. Have you ever been so absorbed in something that you lost track of your surroundings? Odds are you probably have. It's a pretty common human experience. Maybe you were walking down the street on your phone, and at the last minute you managed to swerve out of the way of a street lamp on the sidewalk. Or, let's be honest, you might have smacked straight into it. It's totally okay. I do it more than I would like to admit. And afterwards, you are either chewing yourself out for not being attentive enough, or, if you're like me, you are nursing an aching bump on your head. But you, in the moment, were so absorbed in what you were doing that you couldn't see the pole. You only have enough attention to focus on so many things at once. But just where is that limit? There's a lot of data coming at us all the time. According to a study by Jiyu Zhang and Marcus Meister, our brains take in a staggering 1 billion bits of information per second. This is everything that we encounter with all of our senses all at once. The sensation of you sitting or breathing, seeing, and hearing, of that 1 billion bits per second, we only consciously feel reality at 10 bits per second. So of the billion bits that we take in, we experience only 10, leaving something like 999,999,999 bits that we are just unaware of every second of every day. So where does it all go? If we really felt all of that input, we would be a mess. It would be constant overstimulation all of the time. We wouldn't get anything done. But it's not like this data just disappears. A theory about where the staggering mass of data goes is that it's shuffled into the subconscious to be figured out later on. We have a really cool video about the subconscious and dreaming. If you'd like to explore that topic more, you can watch it right after this one. But the question that I'm left with is, what does the brain choose out of this massive data set for us to actually experience? If we only feel 0.0000001% of what our brains collect, what makes one piece of information more important than another? And, more importantly, how much of the world do we actually see if so much of it is locked away in our subconscious? Building on that, I want to talk about your eyes. They look really nice, by the way. But I'm even more interested in how they look. When you look at something, you feel as though your eyes are still. They're fixed on whatever you are looking at. But your eyes are actually moving the whole time. While you're softly focusing on the world around you, your eyes are twitching back and forth rapidly in movements called saccades. These micro movements of the eyes are hard to catch, but they move our eyes over key aspects of what we're looking at. Your eyes make these tiny movements 3 to 5 times a second, and it's thanks to these that we're able to see in as much detail as we are. But there is always a catch. Since our focus is spread out over 3 to 5 points every second, the information that is arriving in the occipital lobe of our brain is actually full of holes. But that's not what we see. Odds are, as you're watching this video, my face doesn't look like Swiss cheese. But if it ever does, please tell me. No. There's a good chance that what you're seeing is my entire face, a couch, some shelves. And what you aren't seeing is those gaps in your vision. But why don't you notice them? Well, I had the same question. And as I was researching conscious experience, I was hit by a haymaker of a concept that really drove hallucination theory home for me. According to Seth and many other neuroscientists, our subconscious fills in these holes in our perception with what it thinks should go in these spaces. It doesn't take the time to fill in the full picture before feeding it back to us. It's not working harder to pull in extra information to fill in those gaps. It is guessing what lives in those empty spaces based on what it expects to see. In case that needs repeating, our minds are seeing a fragment of a picture and then painting the rest in real time. Then we experience that image and call it objective experience. Well, that's mind-blowing. Your brain is hallucinating reality to fill in the gaps, and there is further information that suggests that what it is imagining may not even resemble the outside world. In 1996, a study on perception by Kovacs et al. Concluded that while we do take in all of the details of an image that we're seeing, our brains are erasing information that our brains judge to be too improbable, even if that information is staring us right in the face. So the reality that we see is less empirical and more run on vibes than anything else, being either shown to us because it makes sense to our subconscious or discarded if it doesn't. Our brains have the capacity to not only fill in the blanks, but to omit or alter inputs that don't conform with its own internal logic. Everything we are is built on our perception. Without this, we would be barely functional automata with no senses. Our worlds would be confined to the space within our heads with no language to interpret what little life goes on in our closed-off minds. But our senses have helped us model the world around us and pierce the veil of ignorance. We've done much based on our understanding of reality. We've puzzled out rudimentary physics, time, mechanics, engineering. We've uplifted ourselves from simple survival to empire building on a scale unmatched by any other life on our planet. And we've done so on the back of the rules of reality that our senses are relaying to us. In spite of these soaring accomplishments, we are no more aware of reality than we ever have been. Everything that we take for granted is gated by the limits of our cognition and then shackled further by the filters of our language and our culture. Our confidence in the world around us is built on such a small amount of information that our grasp on reality looks less like a mighty fortress and more like a house of cards built on a shaky foundation. We don't see the world as it is, but how it looks after being filtered through our language, our culture, and our subconscious. To some philosophical traditions focused on the nature of truth and our relationship to it, this seems like a death sentence. Our own biology hamstrings us from the very beginning, dooming us to a life where we can't escape Plato's cave. It challenges our beloved ideas of truth, perception, identity, free will, and interpersonal understanding. How well can we rely on our own knowledge when we understand that reality isn't just being reinterpreted in our own minds, but that our minds are showing us the world around us based on a prediction of what it expects to see, not what it's seeing, not even a close guess, but a prediction based on our brain's assumption of what makes sense. We assume that our perception is one-to-one with reality, but the more we learn about the brain, the less likely it seems that our assumptions about reality are correct. We can hear sounds, feel textures, smell aromas, and experience a myriad of sensations, but these experiences don't reflect the real world. They reflect an illusion created by our subconscious to improve our survival. Our favorite food smells and tastes delicious to us because our minds connect that food to sustenance needed to keep us alive. Garbage, waste, rotting food, and sewage are translated in our minds to smell revolting because avoiding contact with these improves our odds of avoiding illness. Our perceptive models didn't evolve to display reality as it really is. It evolved just enough to give us exactly the right information to ensure our continued survival. In the reality that lives outside of our perception, these things don't inherently smell good or bad. They don't even have a smell, per se. It can be a sobering viewpoint to embrace, that our conception of reality is built on such a flimsy foundation. We can't trust our senses to give us the full picture, and our perceptions are influenced to a greater degree than we are often aware by the language that we speak and the culture that we grow up surrounded by. If our brains are continuously generating reality instead of merely receiving it, then our relationship with the world is far more uncertain than common sense suggests. And this calls into doubt our notions of identity and the self. Most people experience themselves as individuals existing independently of their sense of understanding. The belief is that you are the one wielding and shaping your understanding, not the other way around. You, the person, we believe, are doing the observing. Yet neuroscience increasingly suggests that the self is itself a construction, a self-portrait resulting from our senses turning inwards. But now we know how shaky that idea is. Your memories aren't static, forever etched exactly as they are into the bedrock of your gray matter. Time, distance, and even our current emotional state can alter our memories. If your image of you is based on your memories and your senses, then it gets harder and harder to justify that there is a concrete you to begin with. So the self becomes another controlled hallucination. It's a concept that your brain created out of your memories. It's a very useful structure enabling coherent action and interaction with social groups, but that doesn't make it real. A sense of self is an evolutionary boon, and perhaps that's all it is. It may not correspond to any kind of fixed, essential essence of you. Any sense of you-ness is a result of narrative constructed from a continuity of memories. You are less so you, the entity, and more so you, the story. And as with any story, there is always room for reinterpretation and retelling. But as these stories are retold, they begin to shift and morph like a photocopy of a photocopy. The story of you changes with each retelling. This can be both incredibly liberating and deeply unsettling. We don't enjoy having our sense of self called into question. We fear death because it is at its core the end of the experience of us. But at the same time, if identity is as wobbly as neuroscience would suggest, then we are given an incredible opportunity to transform and reimagine ourselves. We aren't trapped by some immutable inner self. We are capable of growth, change, and even wholesale reimagination of our core identity. And I think there is another silver lining that comes with embracing such uncertainty. For one, I don't think that accepting the limitations of our senses should lead to radical skepticism. Our brains evolved to make sense of an overwhelming amount of data and to prioritize our survival and our ability to navigate our surroundings with success. Even if the models generated by the brain may not reflect reality, at the very least, these models seem to be constrained by reality. It becomes less a perfect simulation and more like a map. We lose confidence in the fine details, but the layout is still useful as a guide. More important to me, and I hope you can take it this way as well, is how it teaches us humility. All of us are working with different pieces of the same puzzle. If our experience is a model instead of true observation, then any kind of certainty becomes impossible to justify. We often assume that what we are seeing, hearing, and believing is the way things really are. And yet, different cultures and individuals all experience the world differently. What comes off as self-evident to you may be invisible to someone else. And this insight can foster empathy. When we accept that others genuinely experience the world differently than we do, disagreement becomes less a matter of ignorance or malice and more a natural result of multiple individuals having different mental models. The realization that perception is interpreted on the fly rather than purely objective should encourage both patience in our interaction with others and openness about our own experiences. Recognizing the constructed nature of perception reminds us all that our understanding will never be perfect. We'll never see the full picture. The same grace that you would and should extend to yourself for operating with less than perfect information should absolutely be extended to others. Anyone who claims that they have the world figured out is fooling themselves. If talking about how our brains can cause us to hallucinate reality got your imagination going, then I recommend this video, where we discuss how quantum mechanics can affect our conscious minds. What does the end of the world look like to you? Nuclear war? The technological singularity? Maybe it's a climate catastrophe or some asteroid lurking out in deep space. Perhaps it's fire and brimstone, 7 trumpets and judgment. For all of human history, we've imagined the apocalypse as an event, something loud and cinematic, the final chapter, where humanity fights valiantly against the dying of the light. But there's one theory in physics that terrifies me more than any of those, because according to this theory, the universe may not end with fire or chaos or even suffering. In fact, there may be no apocalypse at all, at least nothing close to what we usually imagine. In this scenario, one moment the universe exists exactly as it does now, galaxies spinning through the dark, stars burning bright, humans laughing, arguing, falling in love, making coffee, and watching videos, just like this one. And then, without warning, reality itself just ceases to exist. Not metaphorically, but literally. The laws of physics that permit matter to exist could instantly rewrite themselves. Every particle, every atom, every field that allows us to function could collapse into an entirely different state. And the worst part is that we would never see it coming, not to even dream of stopping it. It would happen so fast that before your brain could register that something was wrong, you, me, and everything we have ever known would already be gone. This is the theory of the false vacuum decay and its terrifying consequences. In 1977, physicist Sidney Coleman published a paper formalizing the concept of a false vacuum, how it could decay into a true vacuum, and what that decay could potentially mean for the universe around it. This is going to get a little technical, but indulge me for a minute. The second law of thermodynamics tells us that physical systems naturally evolve towards states of greater entropy. Energy spreads out. Differences in temperature tend to even out. Ordered systems tend to become more disordered over time. Left alone long enough, the universe trends towards equilibrium. In quantum physics, the word vacuum doesn't simply mean empty space. Even a perfect vacuum still holds quantum fields, fluctuations, fleeting virtual particles, and whatever dark energy ultimately turns out to be. And like all physical systems, these fields tend towards the lowest energy state available to them. The lowest possible energy state is referred to as a true vacuum. A useful way to picture this is with a landscape of hills and valleys. Now imagine a ball rolling downhill. Naturally, it wants to settle into the lowest valley possible, but sometimes the ball can become trapped in a smaller valley before it reaches the absolute bottom. It appears stable even though a lower state does still exist beneath it. That temporary, seemingly stable condition is what physicists call a false vacuum. In classical physics, the ball would simply remain there unless something pushed it over the barrier. But quantum physics allows for something stranger. Because particles behave as probability distributions rather than fixed objects, there is a tiny chance that the ball could effectively tunnel through the barrier without ever climbing over it. This process is called quantum tunneling, and if the fundamental fields of our universe are currently trapped in a false vacuum state, then quantum tunneling may allow reality itself to suddenly transition into a lower energy configuration, a true vacuum. And unfortunately, we have evidence to believe that our current state exists in a false vacuum. Our universe is governed by a collection of fundamental quantum fields that determine how reality behaves. The strong nuclear force binds quarks together and allows atomic nuclei to exist. The weak force governs certain forms of radioactive decay and the fusion processes inside stars. Electromagnetism governs light, chemistry, and atomic interactions. The Higgs field gives particles mass. Gravity shapes the motion of planets, stars, and galaxies. These fields are not just passive background features of reality. They exist in particular energy states, and those states determine the laws of physics that we experience. You can imagine these fields like balls resting in valleys on a landscape of hills and slopes. Each field naturally wants to settle into the lowest energy state available to it. But just like a ball can become trapped in a shallow valley before reaching the lowest point, a quantum field can become stuck in a temporary state of stability, a metastable state. And that's what a false vacuum is. And if our universe currently exists in one of these metastable states, then quantum tunneling introduces a terrifying possibility. At any moment, one of these fields could tunnel through its energy barrier and fall into a lower energy configuration. It may simply settle into another metastable state, or it may descend into a true vacuum, the lowest energy state possible. And if that happens, the laws of physics themselves could change along with it. If our universe experiences a decay from a false vacuum into a more stable vacuum state, the implications are almost unimaginable. The change itself could be subtle, a slight alteration to one of the underlying fields of reality, but the ramifications would be tremendous. A shift in the Higgs field could alter the masses of fundamental particles and radically reshape the structure of matter itself. A change in the strength of dark energy could affect the expansion of the entire universe. Worse still, a sufficient alteration of the strong nuclear force, the force responsible for binding atomic nuclei together, could destabilize all matter entirely. The scariest part is, from start to finish, from that initial quantum tunneling to absolute cosmological breakdown, the conversion process as the universe decays into a true vacuum would move at nearly the speed of light. By the time we are able to observe the process, we would have at best microseconds to act. We would never know what hit us. Our brains wouldn't even have the time to register that all cosmic order had been overthrown. We would just be there one moment and gone the next. In a follow-up paper published by Sidney Coleman and Frank DeLucia, they had this to say about the process and its implications for us as a species. The possibility that we are living in a false vacuum has never been a cheering one to contemplate. Vacuum decay is the ultimate ecological catastrophe. In the new vacuum, there are new constants of nature. After vacuum decay, not only is life as we know it impossible, so is chemistry as we know it. Nonetheless, one could always draw stoic comfort from the possibility that perhaps over time the new vacuum would sustain, if not life as we know it, at least some structures capable of knowing joy. This possibility has now been eliminated. Joy as we know it may not exist in a post-decay universe. The conditions required for chemistry, biology, and consciousness itself could simply disappear. Matter may no longer organize into stars, planets, cells, or nervous systems. The structures required for thought, emotion, suffering, love, memory, all of it, could become physically impossible. It would be a kind of universal Rubicon, a boundary beyond which reality itself no longer resembles the cosmos that gave rise to us. Once crossed, nothing would ever be the same again. False vacuum decay could occur to any of the distinct energy fields that permeate our universe, and as those fields change, the aspects of reality tied to them would change as well. And the effects wouldn't stop there. Even a decrease in gravity as small as 1% would reduce atmospheric pressures at sea level. Breathing could become noticeably more difficult, with oxygen levels resembling those found in high-altitude, mountainous environments. At larger decreases, the consequences become catastrophic. If gravity is weakened by 20% or more, tectonic forces within the Earth could begin behaving unpredictably as the balance between the planet's internal pressure and gravitational pull breaks down. Mountains would rise, fault lines would rupture, and entire continents would shift. Our sun itself depends on gravity. Gravity compresses the sun's core tightly enough for nuclear fusion to occur. If gravity is weakened significantly, the sun would shrink, dim, and produce far less heat. The Earth would begin to freeze as the planet drifted beneath a dying star. Which is, admittedly, one of the more comforting false vacuum scenarios, because, at least in this version, we don't die instantly. Take the strong nuclear force. The strong force is carried by particles called gluons, and is responsible for binding quarks together. Those quarks form protons and neutrons, which in turn form the nuclei of atoms themselves. Even a tiny weakening of the strong force could be catastrophic. A decrease of just 1% could destabilize much of the periodic table. Elements that are currently stable could suddenly become radioactive as the electromagnetic and weak forces begin overpowering the weakened strong force that holds those atomic nuclei together. As those nuclei destabilize, atoms would begin transforming into other elements, releasing huge amounts of ionizing radiation in the process. And in the worst-case scenario, the strong force weakens so dramatically that protons and neutrons themselves begin to come apart. Matter would no longer be capable of holding itself together. Every atom in the universe could release enormous amounts of energy as the structures underpinning reality itself unravel. A vacuum decay event would present an existential threat unlike anything humanity has ever faced. Nuclear war, climate collapse, pandemics, even the eventual death of the sun, all of these disasters at least exist within the rules of reality as we understand them. There are solutions to these problems. Difficult solutions? Absolutely. Solutions requiring a degree of cooperation and foresight that humanity doesn't exactly have a stellar track record with, but we do have solutions nonetheless. False vacuum decay is different. What exactly are you supposed to do against an event that propagates at nearly the speed of light and has the potential to fundamentally rewrite the laws of physics? You wouldn't even know it had begun until it was already upon you. And even if you built some absurdly advanced sci-fi machine capable of manipulating the fabric of reality itself, it would still be operating within the very laws of physics that the decay event is actively rewriting. It would be like showing up to a shootout only to discover that the other side replaced their goalie with an Abrams tank. You're probably not going to win this one. The advancing bubble of this new vacuum state would not negotiate with us, it would simply overwrite the universe as it passed through. And, strangely, there is a small comfort in that. There would be no long decline, no witnessing the slow collapse of civilization, no horror as the end crept steadily and inexorably towards us. The transition would happen so quickly that your brain would never have time to process what was occurring. The physical structures responsible for consciousness itself would cease functioning before the sensation of fear could even fully emerge. It would simply be the end of our experience, the end of every tomorrow. But hey, at least we wouldn't suffer. I know that's not much, but it's something. We human beings are creatures of continuity. We experience time linearly. One moment leads into the next, and from that sequence we create narrative. And from that narrative we create meaning. We shape the world around us to preserve that meaning, to protect it, or to leave fragments of it behind after we're gone. We build monuments, we write laws, we tell stories. We preserve memories because, in some sense, we are trying to preserve ourselves. We want something of our lives and our struggles to outlast us. Everything we do rests upon an assumption that the world will still be here tomorrow, and tomorrow, long after we've breathed our last. Our civilizations, our institutions, even our sense of self all depend upon predictability. And on paper, we are very remarkable creatures. We climbed our way out of those early years when we sharpened sticks, huddled around weak fires, and startled at shadows dancing against cave walls. We learned to trace cause and effect, to ask not only how the world works, but why. We studied the heavens and found comfort in their repeated motions. The stars returned, the seasons changed, planets traced their familiar paths through the sky, and from that consistency emerged a quiet confidence that even after we're gone, the universe itself will remain. False vacuum decay is a brutal rebuke to that certainty. Past stability does not generate future stability. A bridge that has stood for 1,000 years may still collapse if the ground beneath it shifts. A universe billions of years old can still be catastrophically unstable. We mistake repetition for permanence. As advanced as we are, human beings are terrible at comprehending timescales larger than our own lives. Some of us can barely picture what we'll be doing 5 years from now, and yet we conduct ourselves with extraordinary confidence in the long-term stability of reality itself. We drain resources, destabilize ecosystems, and ignore looming crises because their consequences feel too distant from our present experience to matter emotionally. And maybe that same psychological blind spot extends to the universe itself. Because our cosmos has existed for so long, we instinctively assume it will continue existing long after we're gone. But perhaps permanence is nothing more than probability stretched across time. We already understand that many things are temporary. We know that empires collapse, languages die, continents drift apart, stars burn out, even black holes eventually evaporate through Hawking radiation. But false vacuum decay radicalizes that impermanence. Because suddenly it isn't just objects within the universe that are temporary. The rules governing those objects may be temporary too. Death destabilizes our sense of personal continuity. False vacuum decay destabilizes our confidence in reality itself. It's a kind of cosmic rug pull, a scenario where the foundations of existence suddenly give way beneath us. And honestly, that sucks. We want reality to feel dependable. We want the ground beneath our feet to remain grounded. We want the laws of physics to feel sturdy and absolute. When I sit down to write and record these videos, there is an implicit assumption that the reality that I am describing will continue existing long enough for the words to mean something. But the laws of physics may not be sacred truths written permanently into the fabric of existence. They may simply describe the universe in its current state, a temporary configuration, a provisional set of rules that persist only until reality settles into something else. We developed our senses primarily to detect and avoid threats. Bad weather, predators, disease, violence. We're constantly scanning the world for danger, and because we can imagine terrible outcomes, we can fear them long before they arrive. But I think false vacuum decay just unsettles me so deeply because it slips cleanly through the machinery of fear itself. The entire point of fear is to be able to take action to protect yourself from future harm. But with the false vacuum theory, you can't prepare for it. Anything we built to survive it would simply be overwritten like anything else. Technically, we could detect it, but only in the sense that you could technically detect a bullet after it has already entered your skull. That's what makes false vacuum decay feel like such a uniquely modern form of cosmic horror. Because this isn't really a horror story about pain or monsters or fear of the unknown. It's a story about our irrelevance. The worst case outcomes of false vacuum decay confront us with a kind of absolute helplessness. You can't outthink it. You can't outrun it. You can't beat it. Everything we are, everything we place our pride in, becomes little more than paper held against a tidal wave. There would be no heroes, no martyrs, no last stand, no hope. It is a reminder that reality is under no obligation to preserve consciousness simply because consciousness is capable of reflecting upon itself. The universe doesn't owe us permanence. It may not even owe us compatibility with life itself. For all we know, our current version of reality is merely a temporary arrangement of fields and forces that happened to, very briefly, permit our existence. But strangely, I don't think that realization has to end in despair. Because with acceptance comes a kind of clarity. Even if everything is temporary, the temporary can still be beautiful. Maybe even more beautiful because it ends. A flower made of living tissue is more precious than one made of steel. We would have forever to stare at the steel flower, but the living flower exists only for a moment. And yes, I'm going to be talking about Albert Camus. Again. Camus believed that human existence is fundamentally absurd. Not absurd in the Monty Python sense, though occasionally it is very much that too, but absurd because human beings desperately want meaning from a universe that remains stubbornly indifferent. We ask the cosmos for answers, and the cosmos responds in silence. The false vacuum decay embodies that absurdity perfectly. Imagine humanity thousands of years from now. We've mastered fusion, eliminated disease, engineered prosperity for all. Aging has become optional. War is gone. Everyone even returns their shopping carts properly. Humanity flourishes artistically, scientifically, emotionally. We become wiser, kinder, more capable than anything that we could even imagine in our present moment. And all of that grandeur would still vanish instantly because the universe decided that our vacuum state was inefficient. Not evil, not sinful, not morally wrong, just unstable. A kind of cosmic, it's not you, it's me, before the laws of physics themselves suddenly change. So, what are we supposed to do with a realization like that? Well, Camus would argue something important here. Meaning does not require cosmic permanence. We often comfort ourselves with the idea that the universe is moving towards some greater purpose, but reality really offers no such guarantee. Our story may end suddenly and without explanation. The universe may never justify our suffering or reward our struggles. One day, reality could simply transition into a new state and just erase every trace that we were ever there. And yet, Camus believed there was something heroic in continuing anyway in the face of all of that. In choosing to create meaning even within an indifferent universe, in recognizing that meaning is not something handed down to us by the cosmos, but something that we create ourselves in defiance of its silence. It is hard to let go of human exceptionalism. There's a part of me that just it can't help but believe that our species is destined for something incredible. That one day we will stride across the stars as colossi, coming to know ourselves through the cosmos and the cosmos through ourselves. It's an intoxicating idea, because the alternative is far less comforting. The alternative is that we aren't destined for anything at all, that some random shift in the structure of reality could wipe us out entirely, leaving humanity as little more than a footnote in the history of the universe. I have a visceral reaction to some of the implications behind false vacuum decay. If our vacuum state is only temporary, if reality itself is metastable, then it means our entire cosmos may be the product of a kind of cosmic imperfection. A temporary arrangement of fields and forces that persisted just long enough for life to emerge and become aware of the fact that the universe which created it may actually be unstable. I know this is pride talking, vanity even, but I really don't want that to be true. And yet that's the nature of apocalypse, revelation. The revelation hidden within false vacuum decay is that everything we are, everything that has ever existed or ever could exist, may have emerged from a brief and unstable configuration of reality. And honestly, that hurts. But extinction itself isn't unfamiliar to us, quite the opposite. Extinction surrounds us. Entire epochs of life have risen and vanished long before humanity ever arrived. The dinosaurs ruled this planet for roughly 165 million years. It is a staggering dynasty, a span of time more than 500 times longer than our own species has existed. Human beings have only been around for about 300,000 years. Civilization? Barely 12,000. That's agriculture, cities, writing, philosophy, science, governments, technology, poetry. All of these things emerged in the tiniest sliver of recent history. If you were to compress the entire lifespan of the Earth into a single calendar year, modern civilization appears in the final seconds before midnight on New Year's Eve. We are newcomers, infants compared to the dinosaurs, a blink of an eye compared to the Earth itself. And yet we speak as though permanence is our inheritance. We talk about eternal nations, enduring people, immortal legacies, but history tells us a very different story. Change is not something we escaped through technology. Change is the rule. The universe immediately after the Big Bang barely resembled the cosmos that we inhabit today. The forces separated, matter condensed, stars formed, galaxies emerged. Reality cooled and transformed over billions of years, change after change after change. The universe that we know is already the product of countless transitions. We are simply lucky enough to exist during one phase stable enough to support us. And there is absolutely no guarantee that the universe has finished changing. So maybe humanity is not the end point. Maybe consciousness itself isn't the end point. Maybe our reality is simply another stage in a much longer process. I don't love the idea. I would much rather believe that humanity occupies some central and enduring role in existence. But physics has repeatedly humbled us whenever we have tried to place ourselves at the center of things. We thought we were the center of the solar system, until we learned we weren't. We thought the solar system was the center of the universe, until we learned it wasn't. We thought the Milky Way was the only galaxy, until we learned it wasn't. We aren't the center of anything. But maybe that's what makes us remarkable. Because despite our insignificance, despite our briefness, despite the overwhelming indifference of the cosmos, matter still arranged itself into chemistry. Chemistry arranged itself into biology. Biology learned to look up at the stars and ask questions, to tell stories, to create art, to discover quantum physics. And we didn't accomplish those things because the universe guaranteed us greatness. We accomplished them because we're here. And maybe there's a comfort in that too. Because even if a future vacuum decay erases us entirely, we still participated in the unfolding story of the cosmos. We were still one small part of reality becoming aware of itself, however briefly. And whatever comes after us, whatever strange new state the universe settles into, it would still, in some sense, emerge from the same cosmic process that once gave rise to us. There are other avenues of thought that emerge when considering a metastable universe. One of the more controversial ideas in cosmology is the anthropic principle. Broadly speaking, it suggests that the universe appears finely tuned for observers because only a universe capable of producing observers could ever be observed in the first place. It's a somewhat hand-wavy explanation for why the physical constants of our universe seem calibrated in just such a way that complex life can exist at all. And the apparent stability of our vacuum state feels like an extension of that conversation. A violently unstable universe likely wouldn't remain coherent long enough for complexity to emerge. If reality changed too quickly, stars wouldn't form. Chemistry wouldn't stabilize. Life would never get the chance to crawl out of the mud and start asking questions about the cosmos. We may exist within an extraordinarily narrow band of cosmic possibility, balanced delicately between chaos and order. Too unstable and complexity never forms. Too different and chemistry disappears. Too extreme and consciousness never emerges at all. Through that lens, human existence begins to feel astonishingly improbable. Not impossible, just mind-bogglingly specific. And false vacuum decay only reinforces that feeling of precarious balance. The functioning of reality starts to look less like inevitability and more like precision. Our universe pirouettes on a knife's edge, balanced in just such a way that stars formed, planets cooled, biology emerged, and conscious life became possible. What amazes me is just how narrow that knife's edge appears to be. If you were to alter gravity ever so slightly, the stars would burn differently. Change electromagnetism, and chemistry changes with it. Alter the nuclear forces, and atoms themselves may never assemble at all. Reality begins to resemble less a monolithic machine and more an impossibly delicate watch. Every gear is interlocked with bewildering precision. Push one piece too far in either direction and the whole thing grinds to a halt. Now, to be fair, many physicists dislike this framing. The counter-argument is that we only perceive the universe as finely tuned because we ourselves emerged from those conditions. Fish don't marvel that water is perfectly suited for swimming. Water is simply the environment in which fish evolved. Likewise, a universe incapable of producing observers would never contain anyone around to notice its absence. No observers means no questions, and no questions means no philosophical YouTube channels making hour-long videos about metastable vacuum states. But even with that caveat, I can't help but feel a sense of wonder when thinking about the implications of false vacuums and metastability. Because suddenly, everything about our existence feels improbably specific. Against staggering odds, here we are, experiencing, learning, dreading, and existing, turning our attention away from mere survival long enough to contemplate the fate of the cosmos itself, using mathematics to extract meaning from chaos, arriving at terrifying conclusions about the possible instability of our universe, and still remaining curious enough to keep asking questions. There is something miraculous about that. And I don't mean miraculous in a religious sense, but in a statistical one. Honestly, I think this entire script has been my attempt to come to terms with a concept that initially made me feel profoundly small. I've wrestled with this idea for a while now. I've written and rewritten this script repeatedly because I needed to articulate what actually vexes me about false vacuum decay, because it isn't just a story about poof and we're all dead. It is a story about the fragile continuation of a universe capable of producing things like us at all. Small, temporary, carbon-based organisms that somehow evolved far enough to stop merely surviving and begin asking questions about reality itself. And I realized maybe that is the real apocalypse, the real revelation. Maybe one day the universe will transition into some new configuration and erase every trace of us, and maybe not. But for now, we're here. Tiny, temporary creatures asking impossible questions about an impossibly strange universe. So, you know what? I say let's bask in our insignificance. Enjoy this life we're living in, because nothing matters anyway. I'm not important, and neither are you. But what if we were actually important? And not just that, what if we could become immortals and live forever? Watch this video next to find out how that could be our current reality. You open your eyes in the morning. Light filters through your blinds. Motes of dust hang in the air as your nose is greeted by the familiar scent of your room. You feel your soft bed sheets against you. You hear the chirping of birds, painfully interrupted by that one awful neighbor that loves their new leaf blower. You really wish that thing would get hit by a meteor or something. Anyway, these sensations, both good and bad, ground you, a pact between your brain and the world around you that you are, in fact, here. You're you. You have the memories of you, your childhood, your friends, your struggles, your favorite songs, your high school embarrassments, and your future dreams. Your thoughts are the reflections of your observations of the world around you. But we also know that one, many, or even all of these sensations can be false. Hallucinations can cause any one of our senses to report feeling, hearing, or seeing something that isn't there. Cognitive diseases can make us forget memories that serve as core pillars of our personality, or even create new, fake memories that nonetheless feel real to us. Even with all of that, though, we still have one foundation to fall back on. Our senses might be misfiring and our memories may be falsified, but we have our existence on this earth as a solid, reliable anchor proving that we are who we are, where we are, and when we are. Unless, that is, you're not who you are, or when you are, or where you are. Perhaps you aren't you at all. For all we know, you could just be a brain floating through high-entropy space, assembled at random by the cosmic caprice of particles bouncing against each other in the void. Your memories and sensations could all be false, just quantum happenstance creating electrical signals in your mind. Instead of endless darkness all around you, you see colors, you feel feelings, and you can remember your past as if you were actually there, as if you actually experienced and are still experiencing these things. So my question is, what if everything you were, are, and will ever be only came to exist mere seconds ago in a dead universe? What if you are, in fact, not a real person, but just a Boltzmann's brain? In the 19th century, the physicist Ludwig Boltzmann found himself stuck on a deceptively simple question. Why does time only move forward? As far as we can tell, time flows in one direction, from past to future. The answer is deeply connected to a concept called entropy, which is essentially a measure of disorder. We made a whole video about entropy, which we'll link in the description, but as a quick refresher, entropy sits at the heart of the second law of thermodynamics. The first law tells us that energy can't be created or destroyed, only transformed from one state to another. The second law then adds a catch to that. Every time energy changes form, some of it becomes unusable, and the process can't be perfectly reversed. You can see this happening in your own body. We take in food and convert it into energy through metabolism. Some of that energy powers everything we do, but a large portion of it is actually lost as heat. And heat always spreads out, moving from warmer areas to cooler ones. Entropy is the process behind this spreading out, the gradual evening of energy across space. In low entropy conditions, you get incredible complexity. Stars form, planets gather around those stars, atoms bind into molecules, molecules into proteins, proteins into RNA, and eventually into living cells. Over time, these layers of complexity stack up into something like us. Well, at least most of us. But in a high entropy system, everything falls apart. Energy is so spread out that there's no concentrated heat to drive motion, no gravity strong enough to pull matter together. Particles drift aimlessly, following paths set billions of years ago. As energy thins out, the universe cools towards absolute zero, a state where motion itself on an atomic level grinds to a halt. And what you're left with in this state is an endless dark expanse with no structure, no direction, no meaningful change. And without change, time itself loses meaning. There's no real difference between then and now. Sure, we can measure time using clocks or the motion of planets or any repeating cycle that we choose. But entropy is something deeper. Entropy is time in its rawest form. As the universe moves towards greater disorder, we can trace that movement and see time unfolding. If you wanted to get poetic, you could say that time is moving constantly towards its own irrelevance. But back to Boltzmann. Boltzmann asked a question. If the laws of physics are time-symmetric, meaning that they don't generally care for the direction of time, then why does entropy always increase in the direction that we call the future? And furthermore, why did we start in a low entropy state in the first place? Why didn't the universe start off at, say, high entropy? Now, the theory of the Big Bang wasn't going to be formalized by Georges Lemaitre for another 30 years, and we really lacked a solid grounding for how our universe was formed. This was at the time that Boltzmann said this, by the way. So, Boltzmann proposed a radical idea. What if the universe is actually in a state of maximum entropy already? It's complete disorder, atomic anarchy. However, over a monumental, titanic time span, to the tune of 100 quindecillion years, a high entropy system will experience random fluctuations as atoms bounce against each other. Assuming the system doesn't ever come to an end, every possible combination of particles and packets of energy will eventually occur, including the sudden assembling of an entire grand matrix of galaxies, including one such galaxy that contains the pale blue dot that we call home. So, picture a box full of Scrabble tiles. You shake up the box and you look inside. The tiles spell Gerbilfarb, which, last I checked, is not a word in the English dictionary. But you try again, and again, and again. Hey, maybe you get it on the second try, or maybe it takes 100 tries, 1,000,000 tries, but eventually, with enough time, you shake the box, you open it up, and you see that the tiles spell a real English word. Given enough time and repetitions, randomness can produce order. A boltzmann's brain is the extreme version of that idea. It is a fully formed, self-aware brain that appears out of random fluctuations, complete with false memories and a sense of reality, even though it was never actually born or it never actually evolved from anything. It didn't take long for other physicists to run the numbers and stumble upon something strange. In a universe that lasts forever, it's far more likely for a single brain to randomly form than for an entire universe full of observers to exist the way ours does. In other words, most observers in such a universe wouldn't be people like us. They would be these spontaneous, isolated minds. Going back to the Scrabble example, it is much more likely to shake out the word morning than it is to get the full sentence, my neighbor has no business using his leaf blower at 6 a.m. in the morning. In an infinite or extremely long-lived cosmos, random fluctuations could occasionally produce small pockets of order, and sometimes that order could be something that thinks, feels, and believes they are, even though they're not. There's an existentially devastating implication to this line of inquiry, though. If order arising from a chaotic, high-entropy system over a large amount of time is more likely to create something as simple as a mind versus, say, our Earth in a solar system, in a galaxy, in a universe, then it's much more likely that you, all of what makes you you, everything that you see and feel, all of your memories, are just a brain randomly created in a chaotic cosmic vacuum. Every neuron, every synapse, every electrochemical state appearing in just such a perfect way that it perfectly simulates being. So I want to ask you a question. If all of your memories and your senses were false, yet internally consistent, would being real even matter to you? What would a sense of self even mean when you're the only observer floating in a vast, empty universe? And your brain would feel, it would think, it would remember, and because it can remember, it can build identity. You would feel the grass underneath your feet. You would smell coffee in the morning. You would complain about your just terrible neighbors. But you would have no idea that none of it was real. You're just a space fart, lucky enough to have a sense of personhood. And if that's true, then every assumption you make about your reality is subject then to doubt. Your memories could be fabrications, a coincidental pattern etched into your very coincidental mind. You're an illusion convincing enough to fool even yourself. In a Boltzmann brain scenario, your thoughts are no longer a reliable indicator of reality. I do want to be clear that the odds that you are a Boltzmann's brain are astronomically, almost impossibly low. But the point isn't necessarily to prove that this is true, but to use this idea to ask ourselves questions about our personhood and our reality. To question if being real humans matters to us more than the feeling and experience of being real. René Descartes says, cogito ergo sum. I think, therefore I am. Boltzmann counters, cogito ergo non sum. I think, therefore I'm not. Whether you aren't real or you're the only thing that is real, both have massive implications. Our self-perception is usually based on the information that we take in from other people and from the outside world. If that information is all false, then the foundation of what makes us ourselves disappears in a puff of logic. Not only does our personhood come under attack, but the way in which we observe and measure the world around us comes under fire as well. Existing is terrifying when you're a baby. We cry for a reason. It's only as you grow up and experience more of the world that your fears turn into understanding. We measure the world around us, and this gives us confidence. It teaches us the rules and how to thrive within those rules. However, because of the chaotic nature of high entropy, the signals that make up a Boltzmann's brain's thoughts and senses are incredibly unstable. The reality that it experiences isn't anchored to anything. One moment it might perceive a coherent world, and the next that world could completely change without warning. But there's an even bigger problem. A Boltzmann's brain isn't built to last. It forms by pure chance, a random alignment of particles and electrical activity. There's no structure holding it together and no systems that are maintaining it. The same randomness that brings it into existence can just as easily tear it apart. For a very brief moment, it might experience something like a lifetime, a full reality playing out inside its mind. But in the outside universe, that could be less than a second. And at any point, without warning, the particles drift, the structure collapses, and the mind simply stops. No ending, no fade out to credits, just is becoming isn't in an instant. The cosmos does not owe us continuity. We assume we have a past because of a zoetrope of memories, each leading to the next in sequence. If you're at all familiar with the teleporter dilemma, you know how sticky the issues of memory and personhood can be. For those not in the know, the teleporter dilemma is a thought experiment where one person enters a teleporter, is disassembled at the atomic level, the atoms are beamed off to another teleporter, and the person is reconstructed, atom by atom at their destination. Now, for the record, this person has died. Being disassembled will do that to you. But the person on the other end, at the other teleporter, has the same personality and all the same memories of the original. The person on the other end technically has no history, and they have no past save for what their brains are telling them they have experienced. And there's no doubt, by the way, that in their mind they are them, unless they're aware of the thought experiment, and then things get a little stickier, but that's a bit of a divergence. It would be the same case in the mind of a Boltzmann's brain. The only difference, and perhaps the greatest cruelty, would be that there was no original you. You aren't even experiencing a Xerox of someone else's life, you're just looking at the painted walls of your mind and assuming that they are the genuine article. A Boltzmann's brain would be a stunning affirmation of nihilism. Not only is there no inherent meaning to the universe, but better yet, the person experiencing all of this existential dread isn't experiencing true reality either. Love, pain, joy, despair, annoyance, triumph, and grief, the cruel and beautiful panorama of humanity, reduced beyond the view of even the most cynical of biological fatalists. There will be no discussion of free will not being real in a reality where nothing is real. These wonderful human emotions are robbed of all of their anything. It would be all the easier to reduce our view of our senses and our drives to the mechanical whim of chemical and electrical reactions. I've always been a fan of Carl Sagan's statement that we are star stuff, contemplating the stars, but I never wanted it to take a dark turn like this. I think the most insidious part of this theory is that you would have no way of knowing whether you were or were not the genuine article or whether you were just a brain. This is similar to Plato's allegory of the cave, except there is no exit. What we see in the cave is a projection on the walls, and that only by abandoning our comforts and facing harsh truths can we live beyond the confines of the cave. The similarities between Plato's allegory and Boltzmann's brain end at the mouth of the cave, however. Plato argues that the real world exists outside of the cave. Boltzmann's brain claims that the outside of the cave is just nothing. There's no escape from the cave because there's nothing to escape to. You cannot suddenly wake up from your own life. This all sounds terrifying, or maybe fascinating, or terrifyingly fascinating. By the way, for those asking why our video titles sometimes include the word terrifying, it's because you guys click it more. We always run thumbnail and title tests, and somehow that always wins. I guess we all love to be terrifyingly fascinated. Anyway, I digress. Like I said earlier, this isn't hard science, and I don't want you to think that it is. In fact, the more critically you think about this theory, the more the cracks begin to show in the logic of the whole operation. These inconsistencies can add up enough to take the Boltzmann's brain theory from a mathematical horror story to, well, an interesting thought experiment at best, or a warning flag for bad science at worst. The first and most glaring logical issue here is the method in which the theory itself was formed and is observed. For clarity, the theory posits that you have more chance of being one of these Boltzmann's brains than you do have a chance of being an observer that evolved naturally from a highly ordered system like our current observable universe. But if we are mathematically more likely to be one of these brains, then our observation of the rules of the universe are also just byproducts of a hallucination, which means that the very foundation of the theory just sort of crumbles to dust. In short and very simple terms, Boltzmann's brain kind of disproves itself. Hitchin's razor is a rule and grounds for rejecting certain claims of knowledge. The phrasing of the rule is, what can be asserted without evidence can also be dismissed without evidence. In the reality posited by proponents of Boltzmann's brain theory, it would be impossible to present evidence in favor of the theory, as the reality that the brain observes would be immaterial and entirely subjective. If there was any other theory that provided a basis for a phenomenon and then explained how the phenomenon invalidates the basis, it would be thrown out on the grounds that it's a paradox, and empirical science hates paradox. Boltzmann's brain is no different. Not to mention that the theory fundamentally fails the unspoken axiom of science, the most sacrosanct ruling in scientific discourse, the silly test. I'm kidding, there is no formalized silly test. But some scientists and philosophers dismiss Boltzmann's brain theory because it's just ridiculous. Seth Lloyd, a quantum information scientist at MIT, is quoted on Boltzmann's brain theory. Quote, "They fail the Monty Python test. Stop that, it's too silly. From 50,000 miles up, it is a theory about a brain that all at once calls into question everything about our nature and the world around us, but also tears itself down in the same stroke. It's too sensationalist and not nearly rational enough for some. There's also no accounting for why our reality, as ordered and mathematically complex as it is, appears that way when there would be no logical basis for the formation of these systems in a mind that is imagining everything around it. Should a mind like this exist, there would be no onus and no driving force behind it experiencing a reality based on such well-ordered rules. The brain wouldn't be limited by any formal logic, and so could imagine a red world under a pink sky where water flows upwards into an infinite hole in the sky, that sort of thing. There would be no guardrails for reality in one of these imagined spaces. Not to mention, there is the all-powerful, philosophical masterstroke. Yeah, so what? These three words have done considerable damage to the simulation theory crowd, and the effect on the Boltzmann's brain theory is equally devastating. If you know you live in a fake reality and you know there's nothing you can do about it, then the best course of action is to shrug your shoulders and live as authentically as you would have otherwise. Even if the truth of the universe is that you are just a wisp of thought in an eternal plane of high entropy, the truth of your existence, real or false, is what you observe. In science, Boltzmann's brain theory is actually used as a flagging device. Any cosmological theory that leads to a higher likelihood of one of these brains existing than a regular observer is dismissed on the grounds that the theory is therefore self-defeating. It is worth noting that this theory emerged as one of two possible solutions to the question of why we observe a low entropy universe instead of a high entropy universe. The first solution advanced by Boltzmann was that the universe did indeed start in a state of incredibly low entropy for some reason, and is simply unfolding from that state to a state of high entropy. This theory, especially that thorny "for some reason," was, after all, vindicated 30 years later when the theory of the Big Bang was formalized. The Big Bang was the perfect solution to the problem. It was mathematically viable, philosophically satisfying, and it provides all the necessary conditions to create a high-order system, like our galaxy, which in turn throws off the probabilistic math of Boltzmann's brane theory. The second theory, Boltzmann's brane theory proper, was quickly relegated to the realm of thought experiment. That said, I think it is a very useful thought experiment. It forces us to ask ourselves some very prickly questions. If nothing was real, what would you choose to place value in? Would there be anything of value to you anymore? If you can go about your life knowing that it isn't real, well, how would you? Does love mean anything to you at that point? What about sadness? What's important to you? The absolute truth or something that feels true? Is it still possible to live an authentic and satisfying life in a system that invalidates everything you think you know about the world around you? What's our ethical responsibility to ourselves and the world around us if we can't be confident that anything that we observe is actually real and happening? Good and evil are moral constructs. We project them onto the world based on societal norms and our own subjective rubric. This subjectivity has driven endless debate on the nature of morality and how a moral actor would navigate the world. It's in the mapping of our subjective expectations onto objective reality that friction emerges between the two. This issue goes from ontologically gripping to a complete philosophical cluster frag when viewed through the lens of a constructed reality existing only within the mind. Subjectivity becomes objectivity as the observed universe transforms from something tangibly outside of ourselves to a mere sensory hallucination. What's the nature of endeavor in a space like this? As the matter comprising of Boltzmann's brane cools and draws closer and closer to absolute zero, the tendency of the constituent matter making up the mind would be to decohere. The mind would fall apart. An individual mind undergoing this would be a thinking actor one moment and then would just dissipate the next. If we accept these conditions and the potential for a very abrupt end to our experience, it would invalidate the nature of labor. Everything that we undertake, be it labor or leisure, is undertaken to achieve a future end. We work to make money so we can build towards a personal goal. We relax to unwind and recenter ourselves. The idea that midway through anything the plug could just be pulled on our experience can be galling and may even call into question why we strive for anything at all. We're forced to reconcile with a nature fundamental to more than just the theory of Boltzmann's branes. That any given moment, everything we've accomplished can be undermined. We can either turn away from all endeavor and close ourselves off from potential failure, or we can try anyway, knowing that nothing is permanent, but also knowing that the process can be the end within itself. I mentioned René Descartes earlier, and I can't let the opportunity go by to talk about a concept in Cartesian science and philosophy called the malicious demon. Descartes toyed with the idea of imagining a demon bent on challenging every one of his preconceptions. This demon would be capable of altering the senses of the individual until their perception of the world around them, touch, taste, sight, sound, and smell, are all of a false reality. Through this imaginary device, Descartes could challenge his old assumptions and biases when reasoning. And just like Descartes' malicious demon, the Boltzmann's brane theory can be useful for challenging old dogma. It turned out that it was very easy to temporarily abandon an idea, no matter how well entrenched it is, if the idea was the result of a scheming devil trying to trick you. Boltzmann's brane serves a similar purpose. We've just traded an evil spirit for a quantum event. You can re-examine your biases from the point of view that the lived experience that created these biases never actually happened. By undermining the validity of past experience, we're given the distance necessary to reevaluate our own viewpoints. After all that, I think we can take some of the implications of the theory and push this even further. The state described by Boltzmann, the state of maximum or near maximum entropy, is a state predicted in the theory of the heat death of the universe which, if correct, is the final state of the universe that we inhabit. An entropically high universe would be barren, lifeless, meaningless, and timeless. An unobserved hell of physics incapable of supporting anything resembling an observer, a play without an audience. In a cosmos, described by Willem de Sitter, a cosmos driven to expand faster and faster by the cosmological constant would eventually become the perfect ground for the state of the universe that Boltzmann's brain requires to function. In de Sitter's space, the expansion of the known universe is goaded on by the cryptically named and still scientifically elusive dark energy. This expansion drives matter further and further apart, rarefying matter within local measurements. A direct result of living in a de Sitter space-driven cosmos is that the universe is doomed to an eventual true heat death. If dark energy is driving this acceleration of expansion, the universe would have an infinite or near infinite amount of time for the propagation of Boltzmann's brains. If this state were to ever come about, then Boltzmann's brain theory is back on the table. It's just that these brains would propagate at random and would potentially experience a reality totally different from the ones that we observe. There's even the possibility that, on a long enough timescale, another high-order universe is born and we just start the whole thing over again from the Big Bang or another similar high-order event. Perhaps our perception of the supernatural, ghosts, UFOs, cryptids, and the like, are just random spikes in the electrochemical soup making up a Boltzmann's brain. Our experience of the unreal and the paranormal would be easily chalked up to a chaotic change in the brain's makeup, creating illusions that violate the rules of the brain's reality. If these insular brains were the most probable form of intelligent observer in the cosmos, then our theories and calculations on the likelihood of other life existing in the universe would also be called into question. Our current system states that there's a high likelihood that other thinking observers would exist in a galaxy as old as ours. And yet, we've seen no signs of intelligent alien life to confirm this theory. This notion is referred to as the Fermi paradox. But in a universe that allows for the creation of Boltzmann's brains and probabilistic conditions that make these brains more likely than a high-order cosmos, then the reason for us not making contact with these other races is quite literally inside of our own heads. We don't see aliens because there's nothing outside of the universe that we imagine without our spontaneously forming consciousnesses. I've been a fan of Alan Watts for some time now. Listening to him really helped me out when I was mentally struggling during my university years. And there's a quote by him to the effect of, "On a long enough time scale, all events that are, by their nature, possible will ultimately occur and occur more than once, including a continuity of our consciousness after death and our living of many lives over this massive period of time." No, it's not the most scientifically or logically rigorous theory, but it is comforting to think about that we might get another shot at life after death. There's also the possibility of these shifts in order allowing for the creation of newer and stranger realities than the one we know. If the universe is spatially and temporally endless, then so are the possibilities. And I think all of that is why I still bring this theory up from time to time. Even after you knock the logical stuffing out of it, Boltzmann's brain theory is still interesting and even useful. If you engage with it as though it's true, that we are just temporary spasms of quantum uncertainty in a desolate void, it makes for a thrilling ghost story. And if you consider it a useful thought experiment, it becomes an existential challenge to our personhood that holds our preconceived notions about reality to the fire. Scientifically, it demands of us to make a choice about what paradoxes we will accept in our search for knowledge. It's a canary in the coal mine for theories that invalidate themselves, an early warning against lines of logic that falsify the very ground upon which we build our assumptions. Philosophically, it invites uncertainty. We're forced to confront a potential reality that isn't ours. Are we the sum of our memories, even if these memories aren't real? Is the true nature of a person the atoms that came together to make them, or is it the world that lives inside their head, whether they're real or imagined, that makes them who they are? If you've enjoyed this video, you'll definitely also like this video on quantum paradoxes that really boggle the mind. You look up at the night sky and at first it doesn't feel real. The stars are too distant, too ancient, too impossibly vast for you to fully comprehend. Thousands of tiny lights scattered across an endless darkness, each one a sun, many older than our species itself. And yet somehow, despite all of that distance, they feel familiar, like something buried deep inside of you recognizes them. Maybe that's because, in a very literal sense, you belong to them. Every atom in your body was forged in the heart of a star. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it was born in cosmic furnaces billions of years ago, long before the Earth ever existed. Every atom inside you traveled across the universe for unimaginable stretches of time. And then, for one brief moment in cosmic history, the universe arranged itself into something capable of looking up at the stars in awe. The universe became you. This is the philosophy of Baruch Spinoza, the idea that you, me, every living thing are not separate from the universe, but expressions of it. That consciousness itself is the cosmos becoming aware of its own existence, and that there is no God watching over the universe, but the universe itself is God. In 1929, a rabbi sent Albert Einstein a telegram asking a simple question: "Do you believe in God?" Einstein replied with a sentence that would echo through philosophy, science, and religion to this very day. He said, quote, "I believe in Spinoza's God, who reveals himself in the lawful harmony of what exists, not in a God who concerns himself with the fate and actions of human beings." Baruch Spinoza was born in Amsterdam in 1632, during a time when Europe was consumed by religious conflict and intellectual upheaval. His family were Sephardic Jews who had escaped Portugal during the Inquisition, a time when Jews were tortured, executed, and forced to convert to Christianity. Amsterdam became a refuge for these displaced communities, one of the few places in Europe where they could practice their faith with relative freedom. The Jewish community there was tightly bound together by shared trauma and survival. Religion was not simply belief, it was identity, protection, and continuity. To challenge it was to threaten the fragile structure holding the community together. Spinoza grew up immersed in this world. He studied Hebrew scripture, Jewish philosophy, and religious law. By all accounts, he was brilliant, quiet, and deeply curious, so much so that everyone around him expected he would become a rabbi. But sometime in his late teens, he began to ask dangerous questions. He wanted to know whether scripture should be interpreted literally. He questioned whether God truly intervened in human affairs. He doubted the existence of miracles. He wondered if the soul was really immortal. Today, these might seem like just abstract academic debates, but in the 17th century, these were ideas that could destroy your life. What made Spinoza especially threatening was that he did not merely reject religion in the conventional sense. He dismantled the entire framework beneath it. Most people at the time imagined God as a supreme ruler, standing outside of the universe, guiding history like a king governs a kingdom. God created the world, judged human behavior, rewarded virtue, punished sin, and listened to prayers. Spinoza looked at this image of God and concluded it was nothing more than humanity projecting itself onto the cosmos. Humans imagined God as a giant version of themselves because they could not conceive of reality in any other way. For Spinoza, the universe did not revolve around human desires, fears, or moral dramas. Nature followed laws. Everything unfolded through necessity. The stars moved according to physical principles. Storms formed through atmospheric conditions. Human emotions emerged through chains of causes extending far beyond conscious awareness. There was no divine hand suspending the laws of reality whenever humans demanded special treatment. This was an almost impossible idea for his contemporaries to accept because it shattered the comforting structure of existence. If God does not intervene, then suffering is not part of some cosmic moral narrative. If miracles do not exist, then nature is indifferent to prayer. If humans are not uniquely favored by creation, then we are not the center of reality. Spinoza forced people to confront a universe that operated independently of human wishes. Yet strangely, his philosophy was not cold or nihilistic. In fact, many people who read Spinoza describe the opposite reaction. They experience an overwhelming sense of connection. Because if God is not separate from nature, then every living thing becomes part of the same infinite process. The boundary between self and the universe begins to dissolve. You are no longer a lonely creature trapped in a hostile cosmos. You are an expression of the cosmos itself. This is why Spinoza has fascinated such radically different thinkers across history. Hegel said, quote, "You are either a Spinozist or not a philosopher at all." Nietzsche admired his rejection of free will and divine morality. Freud saw traces of psychoanalysis in Spinoza's understanding of hidden motivations. Even modern neuroscientists and physicists continue to find parallels between Spinoza's vision and contemporary understandings of the interconnected systems in the cosmos. But in Spinoza's own lifetime, these ideas made him one of the most hated men in Amsterdam. At just 23 years old, the Jewish authorities issued the harshest excommunication decree in their community's history. The document is shocking even today. It cursed him by day and by night, forbade anyone from speaking to him, helping him, reading his writings, or even standing within a certain distance of him. He was completely erased from communal life. There was no path for him for forgiveness, no chance for reconciliation. His family was expected to abandon him entirely. Imagine what that meant in the 1600s. Excommunication was not merely social embarrassment or cancel culture the way we think of it today. It was psychological annihilation. Your community was survival. To lose it meant isolation, poverty, and vulnerability. Spinoza lost his entire world because he refused to stop asking questions. And yet, even after all of that, he never responded with bitterness. He quietly left the community, earned a modest living grinding lenses for microscopes and telescopes, and devoted the rest of his life to philosophy. He lived simply, rejected fame, and published many of his works anonymously because he knew how dangerous his ideas were. Assassination attempts were not uncommon for people accused of heresy. At one point, a religious fanatic even tried to stab him in the street. But Spinoza kept writing because he believed humanity suffered from a profound misunderstanding about reality. People believed they were separate from nature, separate from one another, separate from God, and from this illusion emerged fear, superstition, hatred, and endless conflict. His goal was not simply to criticize religion, it was to replace humanity's entire understanding of existence with something radically different. A vision where the universe was one unified substance expressing itself through infinite forms. A reality where every human being, every animal, every plant, and every star were interconnected manifestations of the same eternal process. And at the center of this vision was one revolutionary phrase: Deus sive natura, God or nature. At first glance, the phrase sounds poetic, almost harmless, but in the 17th century it was a philosophical dynamite, because Spinoza was not saying that God created nature or that nature reflected God's beauty. He meant something far more radical, that God and the universe are literally the same thing, one reality, one substance, one infinite existence expressing itself in endless forms. To understand why this idea was so revolutionary, we have to understand the worldview that Spinoza inherited. For most people in Europe at the time, reality was divided into separate layers. God existed above the universe as a transcendental creator. Human beings existed below him as independent souls inhabiting material bodies. Nature itself was treated almost like a machine built by divine hands. There was God, there was humanity, and then there was the physical world. Spinoza looked at this separation and believed that it made no sense. He asked a deceptively simple question. If God is truly infinite, then how could anything exist outside of God? If something exists independently from God, then God would no longer be infinite because there would be something beyond him. Just pause and think about that for a moment. Once you imagine reality as being divided into separate entities, you create boundaries. And boundaries imply limitation, which negates the existence of an infinite being. So, Spinoza arrived at a very startling conclusion. There can only be one infinite being in existence, one infinite reality that contains everything within itself. That single substance is what some people call God, while others call it nature. The two words describe the same thing, just from different perspectives. This idea became known as substance monism, the belief that beneath all apparent diversity, reality is fundamentally one. Think about the ocean. On the surface, you see waves rising and falling, each appearing separate from the others. One wave crashes violently against the shore, while another moves gently through open water. But none of them are truly independent things. Every wave is simply the ocean expressing itself in temporary forms. For Spinoza, human beings are like those waves. You feel separate because your mind draws boundaries around your body, your thoughts, your memories, and your identity. But those boundaries are conceptual. In reality, you are inseparable from the infinite network of causes and processes surrounding you. And we can see this quite literally at play. Every breath you take depends on trees and oceans. Every thought emerging in your mind depends on language, biology, history, culture, and physical laws extending back billions of years. Your existence is not self-contained. It is an expression of the entire universe unfolding in one particular form. Spinoza believed everything that exists is part of the same eternal substance expressing itself through different modes. A mode is essentially a temporary modification of reality, a particular pattern within the whole. Humans are modes. Animals are modes. Galaxies, modes, clouds, forests, planets, memories, and civilization are all finite expressions of the same infinite substance. This also changed how Spinoza understood the mind and the body. For centuries, philosophers struggled with the relationship between consciousness and matter. How can thoughts exist in a physical universe? How does an immaterial soul interact with a material body? Descartes famously argued that mind and body were separate substances, but even he couldn't fully explain how these two fundamental different realities could still affect one another. Spinoza rejected the problem entirely because he rejected the separation beneath it. He argued that mind and matter are not different substances. They are different attributes of the same underlying reality. Humans can perceive reality through two primary attributes, thought and extension. Thought refers to consciousness, ideas, and mental experience. Extension refers to physical matter occupying space. But these are simply two ways of perceiving the same substance. Imagine looking at a coin from two angles. One side appears different from the other, but both belong to the same object. In the same way, every physical event has a corresponding mental aspect because mind and matter are parallel expressions of one underlying reality. Your thoughts are not floating outside of nature, they are nature. This is one reason Spinoza feels strangely modern. Neuroscience increasingly reveals how thoughts, emotions, and decisions emerge from physical processes in the brain. It's not ephemeral the way we once thought it was. Psychology shows how deeply human behavior is shaped by causes outside of conscious awareness. Ecology demonstrates how interconnected living systems truly are. Again and again, modern science moves away from describing things as isolated substances and towards interconnected processes. Spinoza anticipated this centuries earlier through pure philosophy. He even distinguished between two dimensions of nature itself. He called them natura naturans and natura naturata. The first means naturing nature. This refers to the active, eternal processes generating reality, the infinite laws and forces through which existence continuously unfolds. The second means natured nature. This refers to all the finite things produced by those processes, that is, trees, rivers, stars, animals, you and me. In modern language, you could think of it as the difference between the underlying code of reality and the temporary forms emerging from that code. The important point is that nothing stands outside of this system. There is no supernatural realm interrupting nature from above. No external creator stepping in to suspend physical laws whenever humans demand miracles. Everything follows necessarily from the structure of reality itself. For Spinoza, this necessity was not oppressive, it was beautiful. Most people experience reality as chaotic because they only see fragments of it. They judge events according to personal desires and fears. When something benefits them, they call it good. When something harms them, they call it evil. But Spinoza believed these categories reflected human perspective, rather than any kind of objective truth. From the viewpoint of the universe itself, everything unfolds according to necessity. The stars explode, species evolve, civilizations rise and collapse. Human beings fall in love, they suffer, they create art, they wage war, and they die. And none of these are interruptions in reality. They are reality expressing itself through infinite transformations. This perspective changes something fundamental about human identity. You stop seeing yourself as an isolated ego dropped into an alien universe. Instead, you begin seeing yourself as a localized expression of the same forces shaping everything else. The atoms inside your body were forged in ancient stars. The oxygen in your lungs was breathed by countless organisms before you existed. Your consciousness emerged from evolutionary processes stretching back billions of years. The boundary between you and the universe becomes harder and harder to define. And this is precisely why Spinoza terrified religious authorities. Because once God becomes identical with nature, the personal God of traditional religions begins to disappear. The God that most people worship is deeply human. He listens, judges, rewards, punishes, loves, gets angry, forgives, and intervenes. Traditional religion imagines the universe as a moral drama centered around humanity. Spinoza dismantled all of it. God doesn't love you, but hey, neither does he hate you. He has no emotions because emotions imply change, and change implies imperfection. A being who becomes angry or pleased is reacting to events outside of themselves. But for Spinoza, God is infinite reality itself. Nothing exists outside him to provoke those emotional reactions. To Spinoza, God has no preferences, no chosen people, no divine plans for nations or individuals. The universe doesn't revolve around human morality. Nature follows laws with absolute consistency whether humans approve of the outcomes or not. The more I read about Spinoza, the more I feel like he honors the idea of God more than most religious people I've met who treat God like some random genie who grants wishes. Some of these religious people in his day condemned him as the prince of atheists who was secretly trying to destroy religion itself. people who actually read him, had the opposite reaction. Instead of eliminating spirituality, Spinoza transformed it into something vast and impersonal. The Romantic poet Novalis called him the God-intoxicated man because there is something spiritually overwhelming about Spinoza's vision of reality. Instead of imagining God as a distant ruler watching the universe from above, Spinoza dissolves that distance entirely. Every star has suddenly become divine. Every living thing becomes an expression of the infinite. The laws of physics themselves become sacred because they are the structure of God's existence. In Spinoza's universe, there is no separation between the spiritual and the material world. Reality itself is holy. This is why Einstein admired him so deeply. Einstein rejected the idea of a personal God who interfered with nature, but he felt profound awe toward the mathematical harmony of the cosmos. For Einstein, this cosmic intelligibility inspired something close to religious reverence. I think Spinoza would have understood that perfectly. But his philosophy still came with devastating implications for traditional beliefs. There are no miracles in Spinoza's universe because miracles would require God contradicting his own nature. Religious traditions often define miracles as suspensions of natural law: water turning into wine, seas parting, the dead returning to life. But Spinoza argued this idea makes no sense. If the laws of nature are expressions of God's essence, then violating them would mean God acting against himself. Nature cannot break its own laws because those laws are what nature is. When people describe miracles, Spinoza believed they are actually describing events whose cause they simply do not understand. Human ignorance creates superstition. Ancient people saw lightning and imagined divine anger because they lacked scientific explanations. The less people understand nature, the more they project intention onto it. This also transformed his view of prayer. Most religious prayer assumes God can be persuaded to alter reality according to human desires. Like I said earlier, a genie. People ask for victories in war, protection from disease, financial success, or the recovery of loved ones. But for Spinoza, asking God to suspend the necessary order for personal profit reflected a profound misunderstanding of existence. He saw this kind of prayer as a form of narcissism, humans imagining the infinite structure of reality rearranging itself to please their individual wishes. And yeah, that does sound harsh, but Spinoza's goal wasn't cruelty. He believed humans suffered because they misunderstood their place within nature. People cling desperately to fantasies of control because reality feels uncertain and frightening. Religion often comforts this anxiety by promising cosmic justice and divine protection. But Spinoza thought genuine peace could only emerge through understanding reality as it truly is. And reality, in his view, was governed entirely by necessity. Every event emerges from prior causes extending infinitely backwards through time. A storm forms because atmospheric conditions produced it. A war occurs because of political tensions, economic pressures, psychological motivations, and silly, stupid humans. Spinoza believed wisdom begins when you stop viewing yourself as separate from nature and start understanding yourself as part of an infinite process. At the center of this process lies one of the most important concepts in his entire philosophy: conatus, the drive of every living thing to persist in its own existence. Every living thing struggles to continue existing. Plants stretch their way towards sunlight. Animals fight for survival. Humans pursue security, recognition, love, power, pleasure, meaning. Beneath the complexity of civilization, philosophy, and culture, there is a deeper movement driving life forward, a fundamental tendency to persist, to expand, and to express itself. Spinoza called this force conatus. The word is difficult to translate directly because Spinoza meant something broader than a simple survival instinct. Conatus is the essence of a thing to strive to remain what it is. A tree pushes its roots deeper into soil. An animal avoids danger. A human being seeks experiences that strengthen their existence and avoids those that diminish it. For Spinoza, this striving is not something added onto life, it is life itself. You don't simply possess conatus as one feature among others. Your desire to continue existing is the very structure of your being. Basically, every living thing expresses itself through continuous existence. This is why emotions occupy such a central role in Spinoza's philosophy. Emotions aren't random spiritual disturbances or moral failings. They are signals reflecting changes in our power to exist and act. Joy emerges when something increases our vitality. Sadness emerges when something weakens it. Love is the experience of connecting joy to an external cause. Hate is the opposite. Spinoza approached emotions almost scientifically, treating them as natural phenomena governed by understandable laws rather than mysterious forces descending from an outside reality. This was revolutionary at the time because most moral systems before him framed emotions in terms of sin, of virtue, or spiritual strength or weakness. Anger, lust, envy, fear were treated primarily as moral failings. Spinoza saw them differently. He believed emotions followed causal chains, just like weather systems or biological processes. If someone lashes out in anger, that anger did not come from nowhere. It came from prior experiences, from insecurities, from environmental triggers, from physical conditions and psychological associations. Understanding those causes matters more than condemning the person morally. Again, Spinoza shifts the focus from judgment to understanding. But this raises a disturbing question. If every human action arises through prior causes, then what happens to free will? Well, Spinoza's answer remains one of the most worrisome ideas in philosophy. He believed free will, at least in the absolute sense that people imagine it, doesn't exist. Humans feel free because they experience desires internally while remaining unaware of the countless causes shaping those desires. Spinoza gives a famous example. Imagine a stone flying through the air after someone throws it. If the stone were conscious, it might believe it was freely choosing to move forward. It would experience motion while remaining unaware of the external forces determining its path. You think you freely chose your ambitions, your beliefs, your attractions, your fears, and your opinions, but look closely, and those choices begin dissolving into influences that you never consciously selected for yourself. You didn't choose your genes. You didn't choose the culture you were born into. You didn't choose your early childhood experiences, your language, your nervous system, the historical moments that shaped your life, or the social forces currently shaping your perception of reality. Every experience alters your brain and influences future decisions. Experiments repeatedly show that brain activity associated with decisions often happens before the conscious awareness of choosing. Much of what humans call free choice appears deeply conditioned by processes outside of our awareness. Spinoza saw this centuries before brain scans existed. But his philosophy was never meant to trap humanity in fatalism. He wasn't arguing that life is meaningless because everything is determined. In fact, he believed that understanding causation was the path to freedom. A person consumed by rage feels powerful in the moment, but Spinoza would say they are deeply unfree. Their emotional state controls them completely. The same applies to greed, obsession, tribal hatred, and compulsive behavior. When external circumstances dictate your internal state, you are being acted upon rather than acting from understanding. Spinoza distinguished between passive emotions and active understanding. Passive emotions dominate us when we do not understand their causes. Imagine someone insults you online, and your entire day becomes consumed by resentment. Your mind loops endlessly around that event. You replay the argument internally. Your emotional state depends entirely on something outside of your control. In Spinoza's terms, you are experiencing passive effects. Your internal condition is being determined externally. But understanding changes this dynamic. The moment you begin seeing the causes behind human behavior, emotions become less personal. You recognize that the person insulting you was shaped by their own insecurities, experiences, fears, and social conditioning extending beyond the immediate moment. Their actions become understandable rather than purely malicious. And this doesn't excuse harmful behavior, but it transforms your relationship to it. Understanding dissolves hatred because hatred depends on imagining people as freely choosing evil independent of root causes. Spinoza believed that once humans truly understood the forces shaping behavior, compassion would emerge naturally. This perspective radically alters our concept of morality. Most traditional morality revolves around blame and punishment. People are divided into good individuals deserving reward and bad individuals deserving condemnation. Spinoza rejected this framework because it assumes humans exist outside of causality. Instead, he believed ethical life should focus on increasing understanding, cooperation, and human flourishing. A healthy society wouldn't be built primarily on fear of punishment. It would be built on knowledge of human nature and camaraderie. Imagine being caught in a violent current without understanding the ocean. You panic because events feel random and uncontrollable. But a skilled sailor who understands tides and weather patterns navigates the same waters differently. The laws of nature haven't changed or disappeared, but knowledge creates the power to shape your reaction to adversity. This is Spinoza's idea of freedom. Freedom is not existing outside of the universe's laws. Freedom is aligning yourself consciously with reality rather than fighting blindly against it. The more adequately you understand yourself and the world around you, the less you are dominated by confusion and destructive emotion. You become capable of responding rationally rather than reacting compulsively. This transformation leads towards the highest form of human existence Spinoza could imagine. A state where the ego loosens its grip entirely. Where the self begins seeing reality from the perspective of eternity itself. Spinoza believed there was a way of seeing reality that could fundamentally transform human existence. He referred to it as under the aspect of eternity. Most people experience life from an intensely narrow perspective. The human mind is trapped inside immediate concerns. Personal anxieties dominate your attention. Your daily frustrations feel enormous. Social conflict becomes all-consuming. The ego interprets every event in relation to itself. Someone criticizes you and it feels catastrophic. A plan fails and it feels like the universe is collapsing around your desires. Human beings instinctively place themselves at the center of reality. Spinoza believed this limited perspective is the source of much suffering. When you identify completely with the ego, life becomes an endless emotional storm. You cling desperately to pleasure because you fear pain. You become consumed by anger because you experience obstacles as personal attacks against your existence. Fear dominates because everything appears fragile and temporary. But Spinoza argued there is another way of perceiving reality. Stepping back mentally until your individual life becomes part of a vastly larger process. You begin seeing humanity itself as one expression of nature among countless others. You see civilizations rising and falling across history. You see ecosystems evolving over millions of years. You see stars forming from collapsing clouds of gas and exploding into elements that later become living organisms. you realize your body is composed of matter older than the earth itself. Instead of experiencing yourself as an isolated creature fighting against reality, you begin experiencing yourself as part of reality unfolding. Your existence becomes one temporary expression of an infinite process stretching far beyond individual identity. This shift wasn't meant to produce passivity or indifference, no, quite the opposite. Spinoza believed it could free people from destructive emotional patterns and allow them to live more rationally, compassionately, and joyfully. Because when you stop interpreting everything through the narrow lens of ego, hatred becomes much harder to sustain. Most hatred depends on rigid separations between the self and the other. You see another person as fundamentally alien, threatening, or morally corrupt. But Spinoza's philosophy dissolves those boundaries. Every person becomes an expression of the same underlying reality shaped by causes extending far beyond our conscious control. The person you envy, fear, or despise is another mode of the same infinite substance that you are part of. Again, this doesn't mean abandoning moral judgment entirely or tolerating harmful behavior. Spinoza wasn't arguing that suffering and injustice are mere illusions. He understood human cruelty deeply, but he believed understanding the causes behind human behavior creates the possibility of compassion without naivete. This is why Spinoza placed such enormous importance on reason. Today, reason is often imagined as cold logic detached from emotion, but for Spinoza, reason was deeply connected to emotion. The more adequately you understand yourself and reality, the more capable you become of acting rather than merely reacting. And this leads to one of Spinoza's most beautiful ideas: the intellectual love of God. At first, the phrase sounds religious in the traditional sense, but Spinoza means something almost entirely different. The intellectual love of God is the joy that comes from understanding reality itself. It is the emotional experience of perceiving the universe's interconnectedness clearly. It's the feeling that you get when you look up at the night sky, far away from the city lights, staring up at the Milky Way, or standing before an incredibly vast mountain range, or hearing music so beautiful it temporarily suspends your inner monologue and transports you to a different world. Or discovering scientific truths like the golden ratio, quantum mechanics, or string theory that explain the world in strangely unique yet beautiful ways. These experiences often produce a feeling that is difficult to describe: awe, wonder, a strange combination of insignificance but incredible meaning and connection. The ego shrinks, but existence feels larger and more meaningful at the same time. Spinoza believed this feeling could become a stable way of relating to reality through philosophical understanding. The more deeply you comprehend the interconnected structure of existence, the more you participate consciously in the infinite whole. And this participation generates joy because your mind aligns with reality rather than resisting it. In many ways, Spinoza transformed spirituality into understanding. There are striking parallels here with Eastern philosophies, even though Spinoza developed his ideas independently. In Advaita Vedanta, the individual self is ultimately identical with the universal consciousness underlying reality. In Buddhism, suffering emerges through attachment to the illusion of a separate ego. Taoism emphasizes harmony with the natural flow of existence rather than resisting it. Spinoza arrives at similar conclusions through rational philosophy rather than meditation or mystical revelation. And this may explain why his ideas continue feeling so modern. The more I researched him for this video, the fresher his ideas seemed to me. This sounds like the exact kind of message we need in today's world. In the centuries since his death, science has repeatedly revealed deeper layers of interconnectedness within reality. Ecology shows that organisms cannot exist independently from environmental systems. Quantum physics and spooky action at a distance shows that there are particles that can be far from each other and unconnected via space, but will still be interconnected. Neuroscience reveals how constructed yet fluid personal identity truly is. Cosmology shows that every atom in your body originated in ancient stellar explosions. The deeper humanity looks into nature, the harder it becomes to maintain the illusion of complete separateness. Carl Sagan once said, "We are a way for the cosmos to know itself." That sentence could almost summarize Spinoza's philosophy. You are not outside the universe observing it from a distance. You are one expression of the universe becoming conscious. The thoughts occurring in your mind are a part of nature reflecting upon itself. Human awareness emerges from the same reality that produces oceans, gravity, galaxies, forests, and stars. And yet, despite the beauty of this vision, Spinoza's philosophy never replaced traditional religion in the way some Enlightenment thinkers hoped. Because human beings don't live by ideas alone. Traditional religions survived not merely because they offered explanations about reality, but because they created rituals, communities, symbols, music, architecture, shared stories, and emotional belonging. They addressed grief, loneliness, mortality, and the need for collective identity. Spinoza offered humanity a breathtaking philosophical vision. But visions alone rarely satisfy the emotional needs of entire civilizations. Still, his influence quietly spread through history. He helped lay the foundations for the Enlightenment, secular democracy, freedom of thought, and the separation of church and state. His insistence that people should be free to think without persecution became central to modern liberal societies. Philosophers, scientists, psychologists, and artists continued rediscovering him generation after generation. Because Spinoza offers something increasingly rare in the modern world, a way of feeling spiritually connected to existence without abandoning reason, a vision where science and awe coexist, where humanity is neither the center of creation nor meaningless dust floating through emptiness. You are something stranger than either of those extremes, a temporary pattern within an infinite process, a fragment of the universe becoming aware of itself, and for a brief moment, through you, the cosmos opens its eyes. When Baruch Spinoza died in 1677, he left behind no church, no movement, no disciples marching through Europe carrying his message. There were no temples dedicated to his philosophy, no rituals built around his vision of the universe, no masses gathering weekly to celebrate the unity of existence. And yet, centuries later, his ideas survived while many of the authorities who condemned him faded into history. That survival says something important, because Spinoza understood reality in a way that humanity can never move on from. The modern world often feels psychologically fragmented. People experience themselves as isolated individuals disconnected from nature, from one another, and even from their own minds. Technology amplifies this feeling. Social media turns identity into performance. Consumer culture encourages endless comparison and dissatisfaction. Modern life surrounds people with stimulation while quietly eroding any stable sense of meaning or belonging. People are more connected technologically than ever before, yet loneliness and anxiety continue rising across the world. We possess immense technological power while remaining psychologically divided against ourselves. Political polarization fractures societies into hostile tribes incapable of understanding one another. Underneath all of these crises lies the same illusion Spinoza spent his life attacking, the illusion of separateness, the belief that humans stand apart from nature rather than within it, that individuals exist independently, that nations can pursue endless self-interest without consequence, that the ego is the center of reality. Spinoza offers no easy solutions to these problems. In fact, what he offers is extremely difficult. A vision where every living thing belongs to the same unfolding process, where understanding replaces hatred, where freedom emerges through knowledge rather than domination, where spirituality is found not in escaping the universe, but in recognizing your inseparability from it. And this doesn't mean passively accepting injustice or abandoning compassion. Spinoza strongly believed in improving human society. He defended democracy, freedom of speech, and intellectual liberty during a period when those ideas were genuinely dangerous. He believed understanding human nature could create more rational and humane political systems. But he also believed wisdom begins when humans stop imagining themselves separate from the rest of existence. And perhaps this idea matters now more than ever, because in a fragmented world, the idea that existence is fundamentally one carries enormous emotional power. You are not a disconnected observer floating through an alien cosmos. You are composed of ancient stars. Your mind emerged from the same universe producing black holes and oceans. The boundary between you and reality is thinner than you think. For a brief moment, the universe arranged itself into someone capable of asking questions about its own existence. Someone capable of wonder. Someone capable of looking up at the stars and realizing that the matter observing the cosmos is no different than the cosmos itself. You were never separate from the universe. You are the universe experiencing itself. Up, down, left, right. When I say